Hello there, and welcome back. The universe is a remarkably quiet place for a room filled with so many explosions. We tend to think of the night sky as a static gallery, a fixed collection of distant lanterns hung by a very patient decorator. But the reality is far more fluid and, occasionally, far more unsettling. Tonight, we are looking at a specific point in the dark, a coordinates-based ghost that has recently begun to whisper. It started as a smudge, a tiny, inconsequential pixel on a digital plate that should have remained blank. This is the story of 3I Atlas, a visitor that arrived without an invitation and refused to follow the rules of the house. In the cold, thin air of the high deserts where our telescopes live, the data began to stack into a shape that defied the standard models of celestial mechanics. We are used to rocks. We are used to ice. We are used to the predictable, looping orbits of things that have lived in our neighborhood for 4 billion years. But this object moved with a strange, purposeful grace that suggested it had seen other suns and felt the pull of other, much more distant fires. What if the panic in the scientific community isn't born from a fear of collision, but from a fear of recognition? Imagine standing on the edge of a frozen lake at midnight, realizing the rhythmic tapping you hear isn't the ice shifting, but something underneath trying to get out. This sense of cosmic intrusion echoes the ancient myths of the Ouroboros, the serpent that circles the world, reminding us that eventually, everything that goes out into the void must find its way back. As we settle into the silence of the evening, let the weight of your blankets ground you against the spinning of the earth. If you are listening, I would love for you to tell me what time it is in your corner of the world and where you are finding your stillness tonight. Close your eyes now, because to see what is coming, we don't need light. We need to understand the dark. The smudge is growing, and the math is starting to scream. The story begins in the blue hour, that fragile moment when the sun has dipped below the horizon, but the stars have not yet fully claimed their territory. You are standing in the control room of an observatory perched on a dormant volcano in Hawaii, where the air feels sharp and dry, tasting faintly of ozone and ancient dust. The telescopes are slewing, their massive gears humming a low, mechanical lullaby that vibrates through the soles of your shoes. On October 29th, 2025, a routine sweep of the northern sky by the Asteroid Terrestrial Impact Last Alert System captured something that should not have been there. It was a faint streak of light, barely visible against the velvet backdrop of deep space, moving at a velocity that made the computers hesitate. Normally, a near-Earth object follows a conic section, a predictable curve dictated by the stern hand of gravity. But this object, designated 3I Atlas, seemed to be correcting its course with a subtle, rhythmic precision that looked less like a fall and more like a drift. Scientists are, by nature, a calm group of people who enjoy coffee and rigorous peer review, but there is a specific kind of silence that falls over a room when the physics stops making sense. Imagine a pebble being dropped into a pond, but instead of a splash, it produces a musical note. That is the level of anomaly we are dealing with here. The first anomaly was the speed. It was traveling at 67 kilometers per second, far too fast to be bound to our sun. The second was the shape, an elongated sliver that reflected light in a way that suggested a polished, metallic surface rather than the craggy, soot-covered face of a typical comet. The third anomaly, and perhaps the most distressing for the astrophysicists, was the outgassing. Most comets leave a tail of vapor as they heat up, a beautiful, messy signature of their melting hearts. 3I Atlas left nothing. It moved through the vacuum as clean as a needle through silk. As we look closer, we find ourselves echoing the thoughts of Dr. Avi Loeb and his colleagues, who have long suggested that our solar system might be a high-traffic zone for things we are only just beginning to perceive. Is it a rock? Is it a relic? Or is it a mirror, reflecting our own technological infancy back at us? The air in the observatory remains still, but the data on the screens is frantic. We are seeing a visitor that doesn't care about our labels or our panic. It is simply passing through, a lonely traveler in an ocean of black. You can feel the vastness of that ocean now, pulling at the edges of your consciousness. The earth breathes beneath you, a heavy, slow respiration that reminds us of our own smallness. We have spent centuries looking for life in the stars, but we never quite prepared for the possibility that life might be looking for a parking spot. To understand why this tiny spark of light has caused such a stir, we have to look back at the history of our own skywatching, to the moments when we first realized that the heavens were not a ceiling, but a door. This object is the third of its kind ever detected, a member of a rare class of interstellar interlopers that have crossed the great gulf between stars. The first was Oumuamua, a name that translates to scout or messenger, which arrived in 2017 and left us with more questions than answers. Then came Borisov, a more traditional comet that at least had the decency to look like one. But 3I Atlas is different. It is closer, faster, and far more deliberate in its trajectory. The panic isn't about an impact. The math shows it will miss us by millions of kilometers. The panic is about what it represents. It is a reminder that the fence around our backyard is much lower than we thought. As the telescopes continue to track its progress, we begin to realize that we are no longer just observers. We are witnesses to a cosmic event that bridges the gap between science and the sublime. The data is a map, and the map is leading us into the unknown. But even as the mystery deepens, the rhythm of the universe remains steady. The stars do not blink, they simply watch. And as we drift further into the night, we prepare ourselves to follow the trail of 3I Atlas into the heart of the great silence. To understand why a few decimal points on a computer screen can cause a global community of rational thinkers to lose their collective composure, you have to appreciate the sheer, stubborn reliability of gravity. Gravity is the universe's most predictable accountant. It demands that every object, from a grain of dust to a supermassive black hole, pays its taxes in the form of a specific, calculable path. When you look up at the moon, you are seeing a billion-year-old promise kept by the laws of physics. But 3I Atlas is breaking those promises. As we transition from the initial shock of discovery into the phase where the evidence deepens, we find ourselves staring at trajectories that refuse to settle. In the quiet corridors of the European Southern Observatory, the atmosphere is heavy with the smell of old paper and the hum of high-performance servers. You are sitting at a desk, watching the simulation of the object's path through our inner solar system. The red line representing the visitor should be a perfect hyperbola, a smooth curve that slingshots around our sun and exits back into the dark. Instead, the line is wobbling. It is a deviation of only a few centimeters per second squared, a tiny fraction of a heartbeat. Yet, in the world of orbital mechanics, a centimeter might as well be a kilometer. This phenomenon is what scientists call non-gravitational acceleration. When a comet approaches the sun, it heats up, and the ice buried within its core turns to gas, erupting in jets that act like tiny thrusters. This is the dirty snowball model we have taught in schools for decades. However, 3i Atlas has shown no signs of a coma, no cloud of dust, no glowing tail of ionized gas. If there is no outgassing, what is pushing it? This is where the quiet humor of the universe reveals itself. We are looking at something that is moving because of a force we cannot see. Some suggest it is solar radiation pressure, the gentle push of sunlight hitting a wide, thin surface like wind hitting a sail. For this to work, 3i Atlas would need to be incredibly thin and remarkably light, perhaps only a few millimeters thick, but hundreds of meters long. Imagine a sheet of tin foil the size of a city park, tumbling through the vacuum. This leads us to the impossibility stack. Nature does not typically manufacture city-sized sails. Nature makes rocks. Nature makes lumps of frozen methane. Nature does not make sails. The deeper we look into the data, the more the evidence suggests that we are witnessing a phenomenon that challenges our definition of natural. In the winter of 2025, the James Webb Space Telescope turned its massive, golden eye toward the coordinate where the object was expected to be. What it found was a thermal signature that was far too consistent. A spinning rock should flicker as its different faces catch the sun, but 3i Atlas remained steady, its heat signature a flat line on the graph. It was as if the object was maintaining a specific orientation, perhaps to maximize its exposure to the sun's rays, or to keep a certain side pointed toward us. In the silence of the lab, you can almost hear the gears of the scientific mind grinding. We are trained to look for the simplest explanation, the Occam's razor, approach that says the most likely answer is the one that requires the fewest assumptions. But what do you do when every simple answer is proven wrong by the math? You find yourself reflecting on the history of our species' ego. We once thought the Earth was the center of everything, then the sun, then the galaxy. Every time we find something we don't understand, our first instinct is to try and fit it into our existing boxes. We call it a dark comet or a hydrogen iceberg, terms that sound scientific, but are actually just placeholders, for we have no idea. The humor lies in our desperation to name things. If we can name it, we feel we can control it. But 3i Atlas remains nameless in its essence, a sequence of characters that represents our attempt to catalogue a ghost. The tension in the scientific community isn't a loud, shouting panic. It is a quiet, late-night anxiety that comes from realizing your map of the world is missing a continent. You are walking through the hallways of a university at 3 in the morning, the linoleum floors reflecting the dim emergency lights, and you realize that every textbook in the library might need a new chapter. As the object passes the orbit of Mars, moving toward the inner warmth of our world, the sensors are pushed to their limits. We are measuring the light curve, the way the object reflects the sun's photons. It isn't just metallic, it is selectively reflective. There are patterns in the light that look almost like a code, or perhaps just the way a complex geometric structure catches the light as it rotates. We are caught in a loop of observation and doubt. Each night, the telescopes collect more photons, and each morning, the researchers find that the new data only deepens the mystery. We are like children watching a shadow on the wall, trying to guess if it is a hand or a monster. But the shadow doesn't care about our guesses. It continues to move, driven by a physics that we are only beginning to glimpse through the haze of our own limitations. The transition from data to philosophy happens slowly, like the way the tide comes in. You start by asking about velocities and mass, and you end by asking about intent. If 3I Atlas is a sail, who built it? If it is a rock, why is it acting like a machine? The human reflection starts to mirror the cosmic perspective. We see ourselves in the visitor, a small, fragile thing moving through a vast, indifferent, dark. We wonder if, somewhere out there, another civilization is looking at a screen, watching a tiny smudge move across their own sky, and feeling the same prickle of unease. The panic is a form of kinship. It is the realization that the universe is far more crowded with possibilities than we dared to imagine. The air in your room feels a little cooler now, the silence of the night pressing in. You are part of this journey now, a passenger on a planet that is currently being bypassed by a stranger. To understand the weight of this moment, we must go further back, beyond the era of digital sensors and space telescopes. We must look at the echoes from the past, the times when our ancestors saw things in the sky that they couldn't explain, and how they wove those mysteries into the fabric of their lives. 3I Atlas is not just a modern anomaly, it is the latest entry in a very old diary. The stars have always been a source of both guidance and terror. As we prepare to move into the next phase of our story, keep your eyes closed and imagine the sky as it looked 10,000 years ago, before the lights of our cities dimmed the fire of the galaxy. The visitor was likely out there even then, drifting through the interstellar void, waiting for its moment to enter the light of our specific yellow star. The evidence is deepening, and the echoes are starting to grow louder. The story of 3I Atlas is a reminder that we are living in a very short window of time. In the grand timeline of the universe, our entire civilization is a flicker, a brief spark in the dark. Yet, in that spark, we have developed the tools to see a visitor from another star system. We have the math to know it shouldn't be accelerating, and we have the imagination to be terrified of what that means. The panic is a sign of our growth. A primitive society might have seen a god or a bad omen. We see a problem in our physics, and that, in itself, is a kind of progress. But as the segments of our night continue, we must face the fact that some problems don't have easy solutions. Some mysteries are meant to be lived in, not solved. The light from 3I Atlas is fading as it moves away from the sun, but the impact of its presence is only beginning to be felt. It has left a mark on our understanding of the vacuum, a ripple in the pond that will continue to spread long after the visitor has returned to the interstellar night. As we drift toward the next chapter, think about the objects you carry with you, the keys in your pocket, the phone on your nightstand. They are all made of atoms that were once forged in the hearts of stars. You are, in a very literal sense, a piece of the cosmos that has woken up and started asking questions. And tonight, the cosmos is providing an answer that we aren't quite ready to hear. The rhythm of the story is slowing down, the sentences stretching out like the shadow of a mountain at sunset. We are moving away from the frantic energy of the discovery and into the deep, resonant echoes of history. The math of unease is becoming the poetry of the unknown. And so, we turn our gaze away from the screens and toward the deep past, where the first observers once stood on hillsides, wondering if the stars were watching them back. To grasp the magnitude of the 3I Atlas anomaly, we must peel away the thin, colorful layer of our atmosphere and look at the universe without the distortion of air or the comfort of gravity. In this domain, the cosmic perspective is not just a poetic idea, it is a brutal realization of scale. We often speak of the vastness of space as if it were a room we could eventually fill with furniture. But space is mostly an aggressive absence of things. It is a vacuum so profound that a single stray atom is a significant event. Into this emptiness comes 3I Atlas, a needle of matter traveling through a haystack of nothingness. To the scientists watching from Earth, the panic arises from a sense of perspective. If you scale the solar system down so that the sun is the size of a grapefruit, the Earth is a grain of salt orbiting 12 meters away. In this model, 3I Atlas is a microscopic speck of dust arriving from a neighboring city, miles across the horizon. The fact that it found our grapefruit at all is statistically offensive to most astronomers. It suggests that either the universe is much more crowded than our models predict, or that the visitor was looking for us. The humor of the cosmic perspective is found in our insistence on our own importance. We watch 3I Atlas and wonder if it is a probe, a message, or a warning, as if we are the only interesting thing to see in the Milky Way galaxy. But from the perspective of the object itself, we might just be a gravitational pothole on a much longer road. Imagine a traveler driving through a vast desert who barely notices a single cactus as they speed toward a distant city. To the cactus, the car is a terrifying, unexplained miracle. To the driver, the cactus is a blur of green against the sand. Scientists are panicking because 3I Atlas is the first car that seems to have tapped its brakes as it passed our particular cactus. On November 12, 2025, the velocity of the object shifted in a way that defied the solar sail theory. It didn't just move away from the sun, it adjusted its trajectory toward the Kuiper belt, the icy graveyard of our outer solar system. This maneuver requires a level of energy and precision that nature rarely provides for free. In the silence of your room, try to envision the sheer speed of 67 kilometers per second. At that pace, you could travel from New York City to Los Angeles in less than 60 seconds. You could circle the entire Earth in 9 minutes. This is not the speed of a falling rock, it is the speed of a messenger. When we apply the cosmic perspective, we realize that 3I Atlas has likely been traveling for hundreds of thousands, perhaps millions of years. It may have been launched when our ancestors were first discovering how to sharpen stones. It has drifted through the absolute zero of interstellar space, a temperature so cold that movement itself seems like a miracle. The visitor is a survivor of a journey we cannot yet comprehend. It has passed the ruins of dead stars and the nurseries of new ones, carrying with it the silent history of its origin. The impossibility stack grows higher when we consider the material composition required to survive such a journey. Most asteroids are held together by little more than gravity and hope they are rubble piles that would disintegrate if they tried to perform the maneuvers 3I Atlas is executing. To stay intact at such velocities while changing direction, the object must have structural integrity that rivals the most advanced alloys created in our laboratories. This is why the panic is shifting into a form of cosmic awe. We are looking at a level of engineering that makes our greatest rockets look like steam engines. We are looking at something that has mastered the vacuum. The air feels cool and still around you, much like the environment 3I Atlas has inhabited for eons. You are breathing in a world of oxygen and nitrogen, while the visitor moves through a world of radiation and void. The contrast is beautiful, a reminder that life is a warm, fragile exception to a very cold rule. As we look through the cosmic lens, the human reflection begins to take a different shape. We realize that our panic is actually a form of ego. We are afraid that 3I Atlas is more advanced than us, more durable than us, and more patient than us. It doesn't need to eat. It doesn't need to sleep, and it doesn't need to worry about the quarterly reports of a space agency. It simply exists, a persistent fact in a universe of theories. The scientists at NASA and the European Space Agency are currently debating whether to send a catch-up mission, a desperate attempt to launch a probe that could intercept the visitor before it leaves our neighborhood forever. But the math is grim. To catch something moving that fast, we would need propulsion systems that currently only exist on paper. We are like children on bicycles, trying to chase a supersonic jet. The humor is dry and a bit stinging. We finally found what we were looking for, and we are too slow to shake its hand. Where are you listening from tonight? Are you tucked away in a quiet suburb, or perhaps in a high-rise where the city hums like a distant engine? No matter where you are, the Earth is currently carrying you at 30 kilometers per second around the sun. We are all space travelers, even if we never leave our beds. The 3I Atlas anomaly is just a faster traveler in the lane next to us. The cosmic perspective reminds us that our boundaries are imaginary. The atmosphere is not a wall, it is a transparent veil. Beyond it lies the true reality of our situation. We are on a small, blue boat in an infinite, dark ocean, and we have just spotted a ship on the horizon. The ship isn't responding to our signals, and it isn't slowing down to dock. It is just passing by, leaving a wake of questions that will take us generations to answer. The tension in the scientific community is the tension of a missed opportunity. There is a fear that 3I Atlas is a once-in-a-species event. If we don't understand it now, we might have to wait another 10,000 years for the next one. This is why the telescopes are working overtime, why the supercomputers are burning through megawatts of power to process the latest pixels. We are trying to catch a glimpse of the great silence before it closes back up. The visitor is a crack in the door of the universe, and we are all squinting to see what's on the other side. The segments of our journey are like the orbits of the planets, each one taking us further from the sun, deeper into the mystery. We started with a smudge on a lens, moved through the math of unease and the echoes of the past, and now we are standing in the middle of the cosmic void, looking back at our home. The Earth looks different from out here. It looks like a place that is very much worth protecting, a tiny island of warmth in a sea of ice. 3I Atlas, by its very existence, highlights the preciousness of our world. It is a reminder that while the universe is capable of producing miracles of engineering or strange, dark comets, it has only produced one Earth that we know of. The panic, then, is also a panic of responsibility. If there are others out there, what do they see when they look at us? Do they see a civilization ready to join the cosmic conversation, or do they see a noisy, fractured world that isn't quite ready for a visitor? The reflection is sobering, yet it is also a source of wonder. We are the ones who get to ask these questions. We are the ones who get to stay awake and watch the stars. As the night continues, let the scale of the cosmos settle into your mind. Let the millions of years and billions of kilometers become a soft background noise, like the sound of a distant river. You are safe in the smallness of your room, protected by the very gravity that 3I Atlas is currently outmaneuvering. The story of the visitor is a story of movement, but it is also a story of stillness. It is about the moment when we stop running and start looking. The light from 3I Atlas is already moving toward the outer planets, toward the cold reaches of Saturn and Neptune. It is leaving the warmth of our inner circle and returning to the dark from which it came, but it has left its mark on us. It has changed the way we calculate the possible. The human reflection We will turn our gaze inward. We will look at what 3i Atlas has done to our collective psyche. We will explore how a single, silent object can change the way we see our history, our future, and ourselves. The transition is smooth, a slow zoom from the rings of Saturn back down to the reflection in a scientist's coffee cup. The universe is a very large place, but tonight it feels a little smaller, a little more intimate. We are part of the experiment, and the experiment is just beginning. History bends, and tonight it is bending toward the heart of what it means to be human in a universe of strangers. To look into the void and see something looking back is the oldest dream and perhaps the deepest nightmare of the human species. As 3i Atlas streaks across our sky, it acts as a cosmic mirror, reflecting not just the light of our sun, but the intricacies of our own collective psyche. We have reached the point in our journey where the data points stop being just numbers and start becoming narratives. In the labs where the lights never turn off, the human reflection is a palpable thing, a mixture of exhaustion, exhilaration, and a very specific kind of existential vertigo. You can see it in the eyes of the researchers who have spent the last 14 days surviving on cold caffeine and the frantic energy of discovery. They aren't just looking at an object. They are looking at the possibility that everything we thought we knew about our place in the universe is slightly, or perhaps significantly, skewed. This is the stage of the story where we stop asking, "What is it?" and start asking, "What are we?" If that exists. The scientific community is currently experiencing a quiet, dignified form of a breakdown. The panic that the headlines speak of isn't a screaming in the streets kind of chaos. It is a breakdown of paradigms. Since the dawn of the Copernican revolution, we have gradually accepted that we are not the center of the universe. However, we have clung to the idea that we are the only ones currently paying attention to it. 3i Atlas suggests a universe that is not only active, but perhaps inhabited by relics, probes, or debris from civilizations that makes our own look like a sandbox. The historical humor here is that we have spent billions of dollars on search for extraterrestrial intelligence programs, pointing huge dishes at distant stars, waiting for a hello in the form of a radio wave. Meanwhile, the universe might just be tossing its old hardware through our front yard, like a neighbor discarding a broken lawnmower. There is a certain humility in realizing that we might be the last people to know about a party that has been going on for eons. As we consider the human reflection, we must talk about the Oumuamua hangover. When the first interstellar visitor arrived in 2017, we were caught off guard. We didn't have the telescopes ready. We didn't have the collaborative frameworks in place. We argued for years about whether it was a rock or a machine. Now, with 3i Atlas, we are determined not to repeat the mistake of indecision. But the more we prepare, the more the object seems to elude our definitions. On December 1st, 2025, a series of high-resolution images from a satellite array suggested that the surface of the visitor isn't just smooth. It is patterned with geometric irregularities that look suspiciously like heat sinks or structural reinforcement. This is the moment where the what-if pivot becomes a heavy weight. If this is a craft, even an ancient, dead one, the human reflection changes from curiosity to a profound sense of obsolescence. We are like a tribe on an isolated island, seeing a steamship for the first time. We can't even begin to describe the engine. We can only talk about the smoke, Think about your own life for a moment, the small, rhythmic certainties that define your days. You wake up, you drink your tea or coffee, you worry about the weather or the traffic. These are the things that keep us grounded. But 3i Atlas exists in a time frame that makes a human life look like a single spark from a campfire. It reminds us that our worries are local, but our context is universal. There is a quiet humor in the way we try to apply human emotions to a silent object. We call it menacing or mysterious, but 3i Atlas is likely as indifferent to us as a mountain is to a butterfly. It doesn't care about our borders, our politics, or the fact that we are currently panicking over its velocity. This indifference is perhaps the hardest thing for the human ego to swallow. We would almost prefer it to be a threat. A threat implies that we are worth attacking. Indifference implies that we are simply not on the map yet. Where are you listening from tonight? Perhaps you are lying in a bed that has been in your family for years, or in a new apartment where the walls still smell of fresh paint. Wherever you are a biological entity that has evolved to survive on a planet with a very specific temperature and a very specific atmosphere. 3i Atlas is a reminder of how narrow that habitable zone truly is. If the visitor is a machine, it was built to survive the radiation of the interstellar medium, the bombardment of micrometeorites, and the crushing loneliness of the void. We, on the other hand, need a blanket and a warm drink to feel at peace. The human reflection is a study in fragility. We are the soft, wet things living on a rock, trying to understand the hard, cold things moving through the dark. The tension in the scientific community is also a reflection of our internal divisions. There are those who want to broadcast a message toward the object, a message to the messenger, and those who believe that silence is our only protection. This debate echoes the great silence theory, the idea that the reason we haven't heard from anyone else is because everyone else is hiding. 3i Atlas is the first time this philosophical debate has moved from the classroom to the situational room. We are debating the etiquette of a first contact that might already be happening in one direction. If the object is a sensor, it has already seen us. It has seen our radio leaks, our lit-up cities, and our frantic attempts to track its path. The human reflection is the realization that we can no longer be just observers. We have been observed. As the segments of our night continue, let this thought settle into your mind like sediment at the bottom of a lake. We are currently part of a global moment of shared wonder. For all our differences, every person on Earth is currently living in the era of the visitor. This shared experience is a rare thing in human history. It is like the moon landing, but without the flag planting or the triumphalism. It is a moment of collective breath-holding. The scientist in the lab, the astronomer on the mountain, and you, lying in your bed, are all connected by a single trajectory. We are all following the same red line on the screen. The humor of our situation is that for all our technology, we are still just looking up and wondering. The atmosphere in the scientific world is shifting from panic to a sort of reverent curiosity. They are starting to see 3i Atlas not as a problem to be solved, but as a teacher to be listened to. Every bit of data is a lesson in a physics we don't yet possess. The way the object handles the sun's gravity, the way its surface reflects specific wavelengths of light, these are clues to a greater understanding of the cosmos. The human reflection is ultimately about our capacity for growth. We are panicking because we are changing. We are being forced to expand our definition of what is possible. And while change is always a bit frightening, it is also the only way we move forward. The visitor is a catalyst, a chemical agent dropped into the solution of human knowledge to see what precipitates out. The great silence will begin to loom larger. We will explore the possibility that 3i Atlas is not a scout, but a survivor, a piece of a story that ended millions of years ago. But for now, stay in the reflection. Think about the people who built the telescopes and wrote the code. Think about the generations of humans who looked at the stars and saw only gods, and how we are the first generation to see the gears of the machine. It is a heavy privilege, but a beautiful one. The air in your room is warm, your breathing is slow, and the world outside is turning toward the morning. But the night is not over yet. There are still many kilometers to travel, and many questions to ask. 3i Atlas is currently passing the orbit of the Moon. Its shadow, if a shadow can be said to exist in the vacuum flickering across the craters that have seen 1,000 such visitors. But this one is different. This one has a name, a designation, and 1,000,000 human eyes following its every move. We are no longer just looking at the sky, we are looking for ourselves in it. The panic is subsiding into a quiet, cinematic tension. We are waiting for the next signal, the next data dump, the next revelation. Until then, we drift. We let the cosmic perspective and the human reflection merge into a single, peaceful state of curiosity. History bends, and tonight, it is bending toward the realization that we are part of something much, much bigger than our own fears. To understand why a few decimal points on a computer screen can cause a global community of rational thinkers to lose their collective composure, you have to appreciate the sheer, stubborn reliability of gravity. Gravity is the universe's most predictable accountant. It demands that every object, from a grain of dust to a supermassive black hole, pays its taxes in the form of a specific, calculable path. When you look up at the Moon, you are seeing a billion-year-old promise kept by the laws of physics. But 3i Atlas is breaking those promises. As we transition from the initial shock of discovery into the phase where the evidence deepens, we find ourselves staring at trajectories that refuse to settle. In the quiet corridors of the European Southern Observatory, the atmosphere is heavy with the smell of old paper and the hum of high-performance servers. You are sitting at a desk, watching the simulation of the object's path through our inner solar system. The red line representing the visitor should be a perfect hyperbola, a smooth curve that slingshots around our sun and exits back into the dark. Instead, the line is wobbling. It is a deviation of only a few centimeters per second squared, a tiny fraction of a heartbeat. Yet, in the world of orbital mechanics, a centimeter might as well be a kilometer. This phenomenon is what scientists call non-gravitational acceleration. When a comet approaches the sun, it heats up, and the ice buried within its core turns to gas, erupting in jets that act like tiny thrusters. This is the dirty snowball model we have taught in schools for decades. However, 3i Atlas has shown no signs of a coma, no cloud of dust, no glowing tail of ionized gas. If there is no outgassing, what is pushing it? This is where the quiet humor of the universe reveals itself. We are looking at something that is moving because of a force we cannot see. Some suggest it is solar radiation pressure, the gentle push of sunlight hitting a wide, thin surface like wind hitting a sail. For this to work, 3i Atlas would need to be incredibly thin and remarkably light, perhaps only a few millimeters thick, but hundreds of meters long. Imagine a sheet of tin foil the size of a city park, tumbling through the vacuum. This leads us to the impossibility stack. Nature does not typically manufacture city-sized sails. Nature makes rocks. Nature makes lumps of frozen methane. Nature does not make sails. The deeper we look into the data, the more the evidence suggests that we are witnessing a phenomenon that challenges our definition of natural. In the winter of 2025, the James Webb Space Telescope turned its massive, golden eye toward the coordinate where the object was expected to be. What it found was a thermal signature that was far too consistent. A spinning rock should flicker as its different faces catch the sun, but 3I Atlas remained steady, its heat signature a flat line on the graph. It was as if the object was maintaining a specific orientation, perhaps to maximize its exposure to the sun's rays, or to keep a certain side pointed toward us. In the silence of the lab, you can almost hear the gears of the scientific mind grinding. We are trained to look for the simplest explanation, the Occam's razor, approach that says the most likely answer is the one that requires the fewest assumptions. But what do you do when every simple answer is proven wrong by the math? You find yourself reflecting on the history of our species' ego. We once thought the Earth was the center of everything, then the sun, then the galaxy. Every time we find something we don't understand, our first instinct is to try and fit it into our existing boxes. We call it a dark comet or a hydrogen iceberg, terms that sound scientific, but are actually just placeholders, for we have no idea. The humor lies in our desperation to name things. If we can name it, we feel we can control it. But 3I Atlas remains nameless in its essence, a sequence of characters that represents our attempt to catalogue a ghost. The tension in the scientific community isn't a loud, shouting panic. It is a quiet, late-night anxiety that comes from realizing your map of the world is missing a continent. You are walking through the hallways of a university at 3 in the morning, the linoleum floors reflecting the dim emergency lights, and you realize that every textbook in the library might need a new chapter. As the object passes the orbit of Mars, moving toward the inner warmth of our world, the sensors are pushed to their limits. We are measuring the light curve, the way the object reflects the sun's photons. It isn't just metallic, it is selectively reflective. There are patterns in the light that look almost like a code, or perhaps just the way a complex geometric structure catches the light as it rotates. We are caught in a loop of observation and doubt. Each night, the telescopes collect more photons, and each morning, the researchers find that the new data only deepens the mystery. We are like children watching a shadow on the wall, trying to guess if it is a hand or a monster. But the shadow doesn't care about our guesses. It continues to move, driven by a physics that we are only beginning to glimpse through the haze of our own limitations. The transition from data to philosophy happens slowly, like the way the tide comes in. You start by asking about velocities and mass, and you end by asking about intent. If 3I Atlas is a sail, who built it? If it is a rock, why is it acting like a machine? The human reflection starts to mirror the cosmic perspective. We see ourselves in the visitor, a small, fragile thing moving through a vast, indifferent, dark. We wonder if, somewhere out there, another civilization is looking at a screen, watching a tiny smudge move across their own sky, and feeling the same prickle of unease. The panic is a form of kinship. It is the realization that the universe is far more crowded with possibilities than we dared to imagine. The air in your room feels a little cooler now, the silence of the night pressing in. You are part of this journey now. a passenger on a planet that is currently being bypassed by a stranger. To understand the weight of this moment, we must go further back, beyond the era of digital sensors and space telescopes. We must look at the echoes from the past, the times when our ancestors saw things in the sky that they couldn't explain, and how they wove those mysteries into the fabric of their lives. 3I Atlas is not just a modern anomaly, it is the latest entry in a very old diary. The stars have always been a source of both guidance and terror. As we prepare to move into the next phase of our story, keep your eyes closed and imagine the sky as it looked 10,000 years ago, before the lights of our cities dimmed the fire of the galaxy. The visitor was likely out there even then, drifting through the interstellar void, waiting for its moment to enter the light of our specific yellow star. The evidence is deepening, and the echoes are starting to grow louder. The story of 3I Atlas is a reminder that we are living in a very short window of time. In the grand timeline of the universe, our entire civilization is a flicker, a brief spark in the dark. Yet, in that spark, we have developed the tools to see a visitor from another star system. We have the math to know it shouldn't be accelerating, and we have the imagination to be terrified of what that means. The panic is a sign of our growth. A primitive society might have seen a god or a bad omen. We see a problem in our physics, and that, in itself, is a kind of progress. But as the segments of our night continue, we must face the fact that some problems don't have easy solutions. Some mysteries are meant to be lived in, not solved. The light from 3I Atlas is fading as it moves away from the sun, but the impact of its presence is only beginning to be felt. It has left a mark on our understanding of the vacuum, a ripple in the pond that will continue to spread long after the visitor has returned to the interstellar night. As we drift toward the next chapter, think about the objects you carry with you, the keys in your pocket, the phone on your nightstand. They are all made of atoms that were once forged in the hearts of stars. You are, in a very literal sense, a piece of the cosmos that has woken up and started asking questions. And tonight, the cosmos is providing an answer that we aren't quite ready to hear. The rhythm of the story is slowing down, the sentences stretching out like the shadow of a mountain at sunset. We are moving away from the frantic energy of the discovery and into the deep, resonant echoes of history. The math of unease is becoming the poetry of the unknown. And so, we turn our gaze away from the screens and toward the deep past, where the first observers once stood on hillsides, wondering if the stars were watching them back. The next anomaly in the quiet profile of 3I Atlas speaks less of active propulsion and more of inherent structural integrity. Imagine, for a moment, a simple, spinning top, perfectly balanced, rotating with smooth, unwavering grace. That stability is what we observe in 3I Atlas. The object rotates once every 16.2 hours. This is considered a relatively fast rotation for an object of this size, and yet, the rotation is remarkably stable. There is no wobbling, no tumbling, just a smooth, steady spin. For a natural object, particularly a comet that is actively outgassing, venting material from its surface, and losing mass through vaporization, you would expect profound instability. The sudden asymmetrical bursts of gas and dust act as tiny, chaotic thrusters, which should perturb the rotation, causing the object to wobble or tumble like a poorly balanced tire. But 3I Atlas is spinning like a well-balanced wheel. This stability in the face of violent, asymmetric outgassing, the very activity that creates the coma, the anti-tail, and the X pattern, is a quiet paradox. It suggests a degree of internal rigidity that is uncharacteristic of a loosely bound cluster of ice and rock. This is one of the profound, quiet lessons of 3I Atlas. The universe is not always in a hurry to reveal its secrets. We are witnessing a cosmic visitor that is breaking our rules in multiple, distinct ways, each anomaly pointing a subtle finger away from the simple, comfortable explanation. The statistical improbability of the alignment with the ecliptic plane, 1 chance in 500, is compounded by the physical improbability of the anti-tail. Both of these are then joined by the statistical rarity of its size and speed combination, which places it in the top 0.1% of expected interstellar objects. And finally, the structural enigma of a stable, rapid rotation in the presence of chaotic, mass-ejecting activity. This is a compelling stack of improbable events, the confluence of which begins to strain the limits of simple, good luck. You must remember the context of the first 2 visitors. Oumuamua, the first, was strange because it accelerated without showing any outgassing. It was inert, yet it moved like a vessel with an invisible sail. 2I Borisov, the second, was a relief because it was normal. It was a classic comet, loud, messy, and entirely predictable. 3I Atlas is the most perplexing because it is both. It has the messy comet activity of 2I Borisov, but it has the perplexing, non-natural, structural anomalies that recall the quiet mystery of Oumuamua. It has taken the unsettling features of the first 2 visitors and combined them into a single, massive, fast-moving puzzle. The current observation campaign is unprecedented. NASA has mobilized more hardware than they have ever aimed at a single comet. The Hubble Space Telescope is taking the highest resolution images possible. The James Webb Space Telescope, the magnificent eye in the dark, is analyzing its chemical composition in extraordinary detail. They are trying to answer the foundational question: what is 3I Atlas made of? Is it the pure ice and rock of a normal comet? Or does its chemical fingerprint reveal an unusual composition, perhaps heavy metals or complex, engineered materials? Furthermore, a whole fleet of other spacecraft is involved in this great, quiet effort. The Transiting Exoplanet Survey Satellite is monitoring its brightness. The SWIFT satellite is searching for any unexpected X-ray emissions. The Perseverance rover on Mars took images during the October flyby. The Europa Clipper, on its way to Jupiter, momentarily turned its cameras toward it. Even the Parker Solar Probe, which dives through the Sun's corona, is positioned to see it from a uniquely angled perspective. This quiet mobilization of resources over a dozen spacecraft plus ground-based observatories, all focused on one object, tells you everything you need to know about the perceived importance of this event. We are throwing everything we have at 3I Atlas because it is the best chance we have ever had to study an interstellar object up close. The proximity of the flyby to Mars, within 19 million miles, was the crucial factor. It was close enough for the Mars Reconnaissance Orbiter to resolve details, to measure composition, and to capture the subtle structure of the object, the very things that are impossible to discern from objects that stay farther away, like the 2 previous visitors. The entire world is now waiting for December 19th, the date of closest approach to Earth, at 270 million kilometers away. While still incredibly far, no danger to our planet, it is close enough to give every major telescope a clear, unobstructed shot. The underlying reason for this intense scrutiny, the thing that NASA is not saying out loud, is the necessity of preparing for the possibility that the anomalies are real. We are collectively, quietly, entertaining the idea that this is not natural. The simplest explanation remains that 3I Atlas is a natural object with highly unusual properties. Comets are complex, and with a sample size of only 3 interstellar objects, we should expect weird things to happen. But science, as Loeb correctly points out, is not about accepting the simplest explanation. It is about following the data, however bizarre or uncomfortable it may be. And the data, in this case, is weird enough to warrant the most serious investigation, including the quiet, systematic search for a technological signature. The Galileo project is looking for the things that scream intelligence: artificial lights, excess engine heat, radio transmissions, and, critically, a course correction that is not easily explained by gravity or outgassing. The stable, rapid rotation is another quiet data point in this technological stack. For a civilization that designed an interstellar probe, a perfectly balanced, stable spin would be a desirable feature, a subtle signature of engineering. It is a property that ensures the internal components are not stressed, and that the instruments are not subject to unnecessary vibration or chaotic movement. We have arrived at a moment in history that our ancestors could only dream of. We are faced with an undeniable object from outside our star system, and its behavior is forcing us to confront a profound possibility. The universe, with its hundreds of billions of stars, is likely full of artificial objects. If even a tiny fraction of those stars develop the technology for interstellar probes, then the galaxy should be teeming with them. Oumuamua, 2I Borisov, and 3I Atlas were all discovered by accident. How many, you must wonder, have we missed? How many quiet messengers have passed through our solar system, undetected, simply because we weren't looking in the right direction at the right time? 3I Atlas is slowly moving away from the sun now, heading back toward the cosmic dark. It is gaining speed as it escapes our sun's gravitational influence. By the time it crosses the orbit of Neptune, it will be traveling at its incoming speed again, 221,000 kilometers per hour, 61 kilometers per second. At that speed, it will take about 20,000 years to travel a single light year. Its journey back into the blackness will be a solitary one. We do not know where it is going, as the forward trajectory does not point to any particular star. It will wander the vast emptiness between stars, a cosmic nomad. But we, the quiet watchers from the third planet, have a brief, profound window to understand its truth. To find that truth, we must zoom out, considering the quiet, ancient history of interstellar travel itself. We must consider the cosmic perspective, a reflection that the European Space Agency has already begun. The red planet, Mars, has always held a special, quiet significance in our exploration of the cosmos, not merely as a destination, but as an advanced celestial observation post. You can imagine the scene on October 2nd, 2025, a date that represents a close encounter of the scientific kind. On this day, 3I Atlas passed within 19 million miles of Mars, an incredibly close distance in cosmic terms. NASA had hardware in the perfect position, a suite of robots acting as silent witnesses to this rare flyby. Chief among them was the Mars Reconnaissance Orbiter, equipped with the high-resolution imaging science experiment camera, a scientific instrument of breathtaking precision. As 3I Atlas drifted past, the orbiter locked onto the comet's nucleus, snapping a set of images that would immediately become the subject of quiet controversy. What the camera captured, according to later reports, was stunning and for a time classified, an X-shaped pattern around the comet's nucleus. It was not the simple, sweeping curtain of a single cometary tail. It was not the subtle, layered light of a double tail. It was an X, 4 distinct structures radiating outward from the center, a geometry that felt less natural and more deliberate. For the scientific establishment, the official NASA line quickly formed a quiet, diplomatic consensus. This was merely dust scattering, the natural, if unusual, result of cometary activity. Nothing to see here, nothing that rewrites the physics textbooks. Just a comet doing what comets sometimes do, but in a particularly high-definition way. But Professor Avi Loeb, the persistent questioner of the universe, was not satisfied with this clean, simple narrative. He pointed out that the X pattern appeared exactly when 3I Atlas was at its closest approach to Mars. It was a moment of maximum chaos, maximum outgassing due to the heat from the sun, and therefore a moment of maximum potential cover. Loeb posed the simple yet profound question: what if the object was releasing subcomponents? What if those radiating lines were not just dust trails, but the subtle, linear paths of smaller, solid objects being ejected from the main body? This is the quiet, scientific pivot that changes the entire story from one of anomalous physics to one of potential technology. The political dimension of this scientific discovery then began to subtly emerge. The high-resolution images from the Mars Reconnaissance Orbiter were not released to the broader scientific community. They were held back, officially under review, pending analysis. While this is a standard procedure for major discoveries, you do not want to release raw data that might be misinterpreted by the public. The delay stretched from weeks into more than a month. Scientists who were eager to study 3I Atlas were denied access to the full, high-resolution files. They received only low-quality, cropped, or processed versions. NASA cited bureaucracy, calibration, and data validation standard procedures that simply take time. But to a mind already attuned to the possibility of the extraordinary, this delay felt like a quiet form of institutional resistance. Loeb, unwilling to accept the easy bureaucratic answer, started asking questions publicly, reaching out to colleagues. This eventually led to the involvement of Congresswoman Anna Paulina Luna, who sits on committees dealing with space policy and national security. Her quiet, political push began, focused on the principle of transparency. If there is even a small chance that 3I Atlas is something unusual, the American people and the global scientific community deserve to know. Science, she argued, cannot happen in the dark. The fact that it took a political intervention to nudge the release of scientific data reveals a deeper layer to how we encounter the extraordinary in the 21st century. It is not just about the observation and analysis of a cosmic phenomenon. It is about the control of the narrative. In an age where we have telescopes that can see billions of light years across space, we are also living in an age of information control. The scientific community, Loeb argues, has a deep, innate bias toward conventional explanations, what he calls scientific conservatism. The fear of being wrong, the fear of looking foolish, can lead to the dismissal of anomalies instead of their rigorous investigation. This quiet tension is the true human drama playing out beneath the stars. Most astronomers look at the data, the anti-tail, the size, the speed, the ecliptic alignment, and see a complex, natural comet. Loeb and his supporters look at the same data and see 8 anomalies, 8 strong reasons to suspect a non-natural origin. As a sleep story narrator, I must tell you, Both sides are, in a quiet way, correct. It is a comet with unusual properties, and those unusual properties absolutely warrant investigation. The conflict is not over the data itself, but over the default assumption we should apply to the unknown. Loeb's argument is profoundly simple, rooted in the history of science itself. He reminds us that every major discovery, heliocentrism, relativity, continental drift, was initially met with skepticism and often ridicule. His philosophy, and the philosophy behind his privately funded Galileo project, is that we must treat every interstellar object as potentially significant until proven otherwise. The Galileo project is dedicated to the systematic search for evidence of extraterrestrial technology, and 3i Atlas is its first major test case. They are collecting every kind of data imaginable: photometric, spectroscopic, and radio data, specifically looking for technological signatures, such as artificial lights, excess heat from an engine, or, most profoundly, a radio transmission. The anticipation of the high-resolution Mars images is immense, a silent, global breath-holding. We are hoping to see more detail on the X pattern, clearer views of the coma structure, and perhaps definitive evidence of discrete, solid fragments separating from the nucleus. This is the key. If the X pattern is merely scattered light from gas and dust, the natural explanation is strengthened. But if the X is resolved into 4 distinct, solid objects, moving with a controlled, technological signature, then the narrative of our existence changes forever. The story, however, does not stop with the classified Mars images. We must now turn our quiet attention to the most damning piece of evidence, the one captured not by a governmental organization, but by the dedicated work of amateur astronomers. This is the observation that confirms the ejection of subcomponents at the staggering speed of 500 meters per second, a speed that suggests not just fragmentation, but a deliberate escape. To understand the true cosmic violence and potential meaning of this ejection, we must examine the date of November 20th, 2025, the day the 3 amateur astronomers, M. Jagger, Greenman, and Prosper, quietly changed everything. On the evening of November 20th, 2025, a handful of dedicated amateur astronomers performed a simple, yet profound, act of witnessing. Using their smaller, backyard telescopes, they captured a stacked image of 3i Atlas, combining 20 separate exposures of 100 seconds each to achieve a deep, clear view. The resulting field of view stretched over 16.7 arc-minutes across, which, at the distance of 3i Atlas, is equivalent to 1.6 million kilometers of space. In that immense volume, they saw something that surpassed the subtlety of the Mars X. They saw, unmistakably, 2 narrow lines shooting sideways from the object. These lines were essentially perpendicular to the axis created by the comet's tail and antitail, forming a geometric X pattern not just around the nucleus, but extending far out into the darkness. The observation was significant because it provided a crucial, temporal clue. These lines represented the trails of smaller objects. Loeb, utilizing this new amateur data, performed a quick, dramatic calculation. He theorized that if these trails were from objects released around perihelion, the comet's closest point to the Sun, on October 29th, 2025, then those objects had traveled approximately 1 million kilometers in the 22 days since. This speed, 1 million kilometers in 22 days, corresponds to an ejection velocity of 500 meters per second relative to the main body. 500 meters per second is the critical number, the velocity that quietly redefines the nature of the entire event. In celestial mechanics, this is escape velocity, the minimum speed you need to break free from the gravitational hold of a parent object and go your own way. This was not a slow drift. This was a violent, rapid separation. You are now faced with the stark, dual possibilities that define the mystery of 3I Atlas. Possibility number 1, the conventional and comforting answer. The object is a natural comet, held together by weak gravitational forces, and the intense heat at perihelion, 770 watts per square meter of solar radiation, simply fractured it. The breakup would eject chunks of ice, and those fragments would then rapidly evaporate, creating the brighter plume of gas and dust that we observed, essentially a cosmic fireworks show. Possibility number 2, the unsettling and profound answer. 3. I Atlas is not a natural object, but a technological mothership, a durable artificial structure with structural integrity beyond simple ice and rock. In this scenario, the intense heat of perihelion would not break it apart, but would merely warm it up. Perihelion, October 29th, 2025, would have been the deliberate, perfect moment for the release of smaller, component probes. The maximum chaos and cover provided by the natural outgassing of the coma would ensure that the ejection of a few small, technological objects would go unnoticed amidst the surrounding cometary activity. Except, of course, the amateur astronomers, with their backyard telescopes and their clear focus, did notice. Loeb argues that we have a simple way to distinguish between these two possibilities, a crucial test for the coming weeks. Natural ice fragments, even with the complex forces acting on them, would behave predictably. Following the laws of gravity and light pressure, they would be inert. But if these ejected components are small, technological probes, they would behave another way entirely. They might maneuver, changing their trajectory to aim for specific targets, perhaps Mars or Earth. Most crucially, they might transmit a radio signal, a technological utterance, and NASA, aware of the quiet possibility, is now listening. Radio observatories around the world are pointed at 3I Atlas, watching, waiting for the faintest whisper of non-natural origin. This brings us to the quiet question of Oumuamua, the first confirmed interstellar visitor, discovered in 2017. Oumuamua also exhibited an unsettling anomaly. As it left the solar system, it accelerated. Objects should slow down as they move away from the sun, but Oumuamua was speeding up. Comets do this all the time. The outgassing from evaporating ice creates a natural rocket engine, a small thrust that accelerates the body. But Oumuamua was silent. It had no coma, no tail, no visible outgassing activity to explain the acceleration. It was acting like a comet that looked like an asteroid. Loeb's explanation at the time, the one that drew the most ridicule, was that Oumuamua might have been a light sail, an artificial, thin reflective sheet pushed by the gentle, constant pressure of sunlight. Other scientists proposed alternatives. Maybe it was a hydrogen iceberg or a cloud of dust. But none of the alternative explanations entirely worked. They all required special pleading, unique compositions, or highly unlikely scenarios. Ultimately, Oumuamua left our solar system, and the mystery remained unsolved, leaving a quiet, lingering question mark in the fabric of space. Then came 2I Borisov in 2019, the second interstellar visitor. Borisov was a comforting presence. It behaved exactly like a comet. It had a tail. It outgassed. and it followed predictable physics. The scientific community breathed a collective sigh of relief. Interstellar objects, they concluded, are just comets and asteroids from faraway places. Nothing special, nothing to worry about. Oumuamua was a strange one-off, an anomaly not representative of the interstellar population. And now we have 3I Atlas, which is, in a quiet, cosmic sense, splitting the difference. It has the coma, the outgassing, and the predictable activity of a natural comet, like 2I Borisov. But it also has the profound, perplexing anomalies of Oumuamua. It is both normal and deeply strange, both natural and profoundly suspicious. This confluence of conflicting evidence, the antitail, the X pattern, the escape velocity ejection, the size and speed, and the ecliptic alignment is why the story of 3I Atlas is not just a scientific curiosity, but a moment of true existential reflection. You may find yourself asking, as we continue this journey through the dark, where did it all come from? Astronomers have traced its hyperbolic trajectory backwards, carefully accounting for the gravitational tug of every planet and the sun. And the answer, as with the most profound questions, is a quiet admission of ignorance. We do not know. Its path does not point clearly to any nearby star system. It could have been wandering the galaxy for millions of years, a cosmic nomad lost in the vast emptiness between the stars. Or, as the technological possibility suggests, it could have been launched recently, with a trajectory designed to evade easy tracing. We simply lack the precise data to make a definitive connection to a single, star-forming source. As you listen, you are participating in a quiet, worldwide vigil. Every major telescope, from the Hubble Space Telescope to the James Webb Space Telescope, is focused on this single, distant dot of light. We are collecting the final, crucial pieces of data before December 19th. We are looking for the telltale signs, for a change of course, for an unexpected maneuver, for a deliberate, non-natural act. We are searching for an answer in the dark. The question now is whether the quiet, stable rotation of the main body will offer another clue. We must next examine its surprising stability in the face of such profound internal activity. On the evening of November 20th, 2025, a handful of dedicated amateur astronomers performed a simple yet profound act of witnessing. Using their smaller, backyard telescopes, they captured a stacked image of 3I Atlas, combining 20 separate exposures of 100 seconds each to achieve a deep, clear view. The resulting field of view stretched over 16.7 arc-minutes across, which, at the distance of 3I Atlas, is equivalent to 1.6 million kilometers of space. In that immense volume, they saw something that surpassed the subtlety of the Mars X. They saw, unmistakably, two narrow lines shooting sideways from the object. These lines were essentially perpendicular to the axis created by the comet's tail and antitail, forming a geometric X pattern not just around the nucleus, but extending far out into the darkness. The observation was significant because it provided a crucial, temporal clue. These lines represented the trails of smaller objects. Loeb, utilizing this new amateur data, performed a quick, dramatic calculation. He theorized that if these trails were from objects released around perihelion, the comet's closest point to the Sun, on October 29th, 2025, then those objects had traveled approximately 1 million kilometers in the 22 days since. This speed, 1 million kilometers in 22 days, corresponds to an ejection velocity of 500 meters per second relative to the main body. 500 meters per second is the critical number, the velocity that quietly redefines the nature of the entire event. In celestial mechanics, this is escape velocity, the minimum speed you need to break free from the gravitational hold of a parent object and go your own way. This was not a slow drift. This was a violent, rapid separation. You are now faced with the stark, dual possibilities that define the mystery of 3I Atlas. Possibility number 1, the conventional and comforting answer. The object is a natural comet, held together by weak gravitational forces, and the intense heat at perihelion, 770 watts per square meter of solar radiation, simply fractured it. The breakup would eject chunks of ice, and those fragments would then rapidly evaporate, creating the brighter plume of gas and dust that we observed, essentially a cosmic fireworks show. Possibility number 2, the unsettling and profound answer. 3. I Atlas is not a natural object, but a technological mothership, a durable artificial structure with structural integrity beyond simple ice and rock. In this scenario, the intense heat of perihelion would not break it apart, but would merely warm it up. Perihelion, October 29th, 2025, would have been the deliberate, perfect moment for the release of smaller, component probes. The maximum chaos and cover provided by the natural outgassing of the coma would ensure that the ejection of a few small, technological objects would go unnoticed amidst the surrounding cometary activity. Except, of course, the amateur astronomers, with their backyard telescopes and their clear focus, did notice. Loeb argues that we have a simple way to distinguish between these two possibilities, a crucial test for the coming weeks. Natural ice fragments, even with the complex forces acting on them, would behave predictably. Following the laws of gravity and light pressure, they would be inert. But if these ejected components are small, technological probes, they would behave another way entirely. They might maneuver, changing their trajectory to aim for specific targets, perhaps Mars or Earth. Most crucially, they might transmit a radio signal, a technological utterance. And NASA, aware of the quiet possibility, is now listening. Radio observatories around the world are pointed at 3I Atlas, watching, waiting for the faintest whisper of non-natural origin. This brings us to the quiet question of Oumuamua, the first confirmed interstellar visitor, discovered in 2017. Oumuamua also exhibited an unsettling anomaly. As it left the solar system, it accelerated. Objects should slow down as they move away from the sun, but Oumuamua was speeding up. Comets do this all the time. The outgassing from evaporating ice creates a natural rocket engine, a small thrust that accelerates the body. But Oumuamua was silent. It had no coma, no tail, no visible outgassing activity to explain the acceleration. It was acting like a comet that looked like an asteroid. Loeb's explanation at the time, the one that drew the most ridicule, was that Oumuamua might have been a light sail, an artificial, thin reflective sheet pushed by the gentle, constant pressure of sunlight. Other scientists proposed alternatives. Maybe it was a hydrogen iceberg or a cloud of dust. But none of the alternative explanations entirely worked. They all required special pleading, unique compositions, or highly unlikely scenarios. Ultimately, Oumuamua left our solar system, and the mystery remained unsolved, leaving a quiet, lingering question mark in the fabric of space. Then came 2I Borisov in 2019, the the second interstellar visitor. Borisov was a comforting presence. It behaved exactly like a comet. It had a tail, it outgassed, and it followed predictable physics. The scientific community breathed a collective sigh of relief. Interstellar objects, they concluded, are just comets and asteroids from faraway places. Nothing special, nothing to worry about. Oumuamua was a strange one-off, an anomaly not representative of the interstellar population. And now we have 3I Atlas, which is, in a quiet, cosmic sense, splitting the difference. It has the coma, the outgassing, and the predictable activity of a natural comet, like 2I Borisov. But it also has the profound, perplexing anomalies of Oumuamua. It is both normal and deeply strange, both natural and profoundly suspicious. This confluence of conflicting evidence, the anti-tail, the X pattern, the escape velocity ejection, the size and speed, and the ecliptic alignment is why the story of 3I Atlas is not just a scientific curiosity, but a moment of true existential reflection. You may find yourself asking, as we continue this journey through the dark, where did it all come from? Astronomers have traced its hyperbolic trajectory backwards, carefully accounting for the gravitational tug of every planet and the sun. And the answer, as with the most profound questions, is a quiet admission of ignorance. We do not know. Its path does not point clearly to any nearby star system. It could have been wandering the galaxy for millions of years, a cosmic nomad lost in the vast emptiness between the stars. Or, as the technological possibility suggests, it could have been launched recently, with a trajectory designed to evade easy tracing. We simply lack the precise data to make a definitive connection to a single, star-forming source. As you listen, you are participating in a quiet, worldwide vigil. Every major telescope, from the Hubble Space Telescope to the James Webb Space Telescope, is focused on this single, distant dot of light. We are collecting the final, crucial pieces of data before December 19th. We are looking for the telltale signs, for a change of course, for an unexpected maneuver, for a deliberate, non-natural act. We are searching for an answer in the dark. The question now is whether the quiet, stable rotation of the main body will offer another clue. We must next examine its surprising stability in the face of such profound internal activity. To truly understand the cosmic significance of 3I Atlas, we must adopt a grander, slower, more mythic perspective, one that stretches beyond the immediate urgency of December 19th. The quiet reaction of the European Space Agency, or ESA, is particularly revealing. The ESA is using this very event, the puzzling, anomalous passage of 3I Atlas, to promote their future Comet Interceptor mission. This is a spacecraft with a single, profound objective: to launch in 2029, settle into a parking orbit around a neutral point in space, and simply wait. It will wait until a suitable target appears, either a pristine comet from the distant Oort cloud, or, and this is the direct, quiet quote from the mission scientist, an interstellar object like 3I Atlas. The mission is a profound statement of scientific intent. It is an acknowledgement that ground-based observation, even with the magnificent tools of the Hubble and James Webb Space Telescopes, has its limits. Observation from Earth can measure brightness, analyze spectra, and track trajectories, but it cannot see fine details, cannot sample material, and cannot measure subtle magnetic fields or particle emissions. To answer the quiet, profound questions that 3I Atlas raises. We need a physical sample, a close-up look, a direct, intimate encounter with the strange. If Comet Interceptor had been waiting in orbit when 3I Atlas arrived, we could have dispatched a probe to fly alongside it, capture high-resolution images, deploy sensors, and perhaps even land a tiny probe on the surface. Imagine the revelations. If it were natural, we would see ice and rock, pristine craters from micrometeorite impacts, and perhaps even complex organic molecules, data that would unlock the chemical composition of material in other star systems. This information, in itself, would be a quiet revolution, a direct sample of material from an alien sun. But if it were technological, the revelation would be one of the ages. We would see the subtle, undeniable signatures of intelligence, manufacturing marks, a non-random, regular geometry, unusual, durable materials, and perhaps even the silent hum of electromagnetic emissions. It would be proof, direct and unassailable, that we are not alone in this vast ocean of stars. This is the ultimate, quiet dream of the Comet Interceptor mission, to chase down the next interstellar visitor, and, by doing so, perhaps rewrite everything we know about our place in the cosmos. The story of 3I Atlas is therefore a profound, accidental gift. It tells us a larger, statistical truth about our galaxy. We have confirmed 3 interstellar objects in 8 years. Before 2017, we had confirmed 0. This is not because the galaxy is suddenly sending more visitors. It is because our detection systems' automated surveys, like the Atlas system that discovered 3I Atlas, are finally becoming good enough to spot them. Astronomers have done the math, and the quiet conclusion is startling. Several interstellar objects, mostly small and fast, pass through the inner solar system every year. We are, as the metaphor suggests, fishing in the ocean with a net that only catches the biggest fish. 3I Atlas is big, perhaps 5 kilometers across, which is why we spotted it so far out. Oumuamua was maybe only a few hundred meters, much harder to see at a distance. We are missing a constant, quiet parade of interstellar debris, and perhaps a constant, quiet stream of interstellar probes. This realization adds a layer of quiet, beautiful anxiety to the story. If artificial objects are being launched by distant civilizations, why would we not expect a few to pass by, looking like comets or asteroids? A strategy of camouflage for a lonely, vast journey. Consider the thought experiment proposed by Loeb. Imagine you are an advanced, long-lived civilization. Interstellar travel is too long for living beings, so you send probes. These machines would need to be small, durable, and intelligent. How would you design them to survive the multi-million-year journey through the cold, radiation-drenched void? You would make them look natural, like a comet or asteroid. To avoid attracting unnecessary attention, you would give them a thick, icy shell for radiation shielding, and use that shell as a source of raw material. You would program them to enter a star system on a trajectory that appears random, an indistinguishable hyperbola, and crucially, you would program them to release smaller, sub-probes when they got close to interesting planets, maximizing their data collection. The description, you may notice, feels profoundly familiar. We must acknowledge the counter-argument, which is profoundly human in its simplicity. Why would aliens care about us? We are, after all, a tiny, watery blue dot, revolving around an average yellow sun. Perhaps they are not interested in us at all. Maybe they are interested in the sun itself, or the giant planet Jupiter, or the icy, mineral-rich Kuiper belt. Maybe they are just mapping the galaxy, conducting a vast, long-term cosmic census, visiting every star system they can reach. Or, in the most haunting of possibilities, we may be witnessing the remains of an ancient mission, a probe launched millions of years ago by a civilization that has long since turned to dust. It has been wandering the vastness ever since, faithfully executing its programming, arriving at our solar system long after its creators ceased to exist. If 3I Atlas is, in fact, technological, we may never know who built it or why, but we will know a deeper, more fundamental truth. We will know that we are not the only fragile intelligence that has reached for the stars, and that we are not alone in the dark. This is the quiet, mythic subtext of the current global observation campaign. The telescopes are looking for ice and rock, but the scientists, and all of us listening tonight, are searching for an echo of another intelligence, a confirmation that the impossible is possible. The questions that remain are profound and specific. What is causing the anti-tail? Are those sideways jets fracture lines or ejected objects? Is the X pattern a natural phenomenon, or is it evidence of a deliberate structural design? And, of course, where did it come from? The mystery of its origin, the lack of a clear, single-star trace, remains one of the quietest, most powerful anomalies. As you settle deeper into the quiet contemplation of these facts, remember that 3I Atlas is a messenger. It came from somewhere, formed around another star, orbited that star for millions or billions of years, and was then ejected by some cosmic event, a gravitational nudge, a supernova shockwave, or a deliberate push. It traveled through the deep, cold void for eons, a solitary pilgrim, until it encountered our solar system. And now it is leaving, heading back into the dark, and we will likely never see it again. The entire journey is epic, cosmic, and humbling. But before it leaves, we have the chance to analyze a final, compelling piece of data: the sheer endurance of the object, its ability to survive the violent, multi-million-year journey. We must reflect on the kind of engineering, either biological or technological, that can withstand the profound indifference of the interstellar void. From the orbit of Mars, the high-rise camera snapped the sharpest images ever taken of 3I Atlas, or tried to. The photos that returned were oddly dark, contrasty, and streaked with interference patterns. The official statement said, "sensor artifact." The unofficial whisper said, "structure, not smooth like ice, angular, intentional." The kind of geometry nature avoids because it looks too much like thinking. Let's drift into that Martian orbit for a moment. Silent, steady, red below, black above. The high-rise camera hums to life, a billion-dollar eye staring into the cold. You can almost feel the anticipation, a mechanical eyelid opening in the thin sunlight. The image begins to build, pixel by pixel, line by line, translating photons into revelation, and then static. At first, it's subtle, a faint interference pattern, a digital shimmer, like someone exhaling across a radio signal. The engineers squint at their monitors. Maybe cosmic rays hit the sensor, someone suggests. Maybe solar noise. But cosmic rays don't make right angles, and solar noise doesn't repeat itself with architectural precision. The next image arrives, darker. The histogram spikes in places it shouldn't. The shape in the frame looks less like a comet and more like, well, something trying very hard not to look like anything. Its edges are clean, too clean, Shadows fall where there shouldn't be surface variation. And there, just faintly, a glint, a perfect 90-degree reflection. That's when the whispers start. The data team runs deconvolution algorithms to clean the image, and the results make it worse. Beneath the interference, faint geometric striations emerge, triangles, plates, grids. Not random, repeating, symmetrical. The kind of order that makes your brain uncomfortable because it feels deliberate. Structure, one analyst says quietly. No, her supervisor corrects. Artifact. But even as she says it, her cursor hovers over the same square patch again and again, as though hoping it will stop looking like a window. ESA's public statement comes fast and flat. The imaging anomalies are consistent with sensor interference caused by reflected solar radiation. That's bureaucratic. For, we don't know what we're seeing, but please don't ask. Internally, though, emails start flying. The word structure appears 17 times in one thread, always in quotation marks, as if politeness could make it less alarming. Imagine being one of those analysts, zooming in until the pixels themselves seem to blink. The surface of 3I Atlas isn't smooth or cratered. It's tessellated, plates arranged in patterns too regular for chance. Some appear overlapping, others recessed, and in one frame, a faint seam runs along the curvature, subtle but unmistakable like a hatch. Of course, no one dares call it that. The official internal term becomes geometric albedo variation. It sounds safe, sterile, boring, but you can't unsee geometry. Nature loves curves, spirals, organic chaos. This looks like design. One engineer writes in her log, "Could this be an illusion from the imaging process?" Another replies, "An illusion that repeats itself identically across 3 instruments." There's no follow-up message. They try to replicate the interference on other targets. Phobos, Deimos, even an old asteroid. Nothing. Only 3I Atlas corrupts images this way. It's as if the object rejects observation, like it knows when it's being watched. The engineers half joke about it. The comet's camera shy, but the laughter is short-lived because the next transmission from HiRISE contains another surprise. A faint electromagnetic pulse, perfectly timed with the camera's shutter. Not a malfunction, a response, as though the act of observation triggered a reply. A pulse that says, in its own quiet way, "I see you too." In a locked sub-channel of ESA's network, a few scientists begin privately discussing the possibility of active surface modulation. They talk about the way certain materials can alter reflectivity based on exposure photonic metamaterials, adaptive nanostructures, the kind of thing still locked inside prototypes on Earth. But this is happening hundreds of millions of kilometers away, and it's working flawlessly. Publicly, the agency releases blurred grayscale stills, carefully cropped to hide the patterns. Enhanced contrast is cited as the reason for distortion. It sounds reasonable until you realize they've enhanced the darkness, not the light. They've made the object less visible, not more. The cover-up, if it is one, isn't about hiding truth. It's about buying time. You imagine the silence inside those offices, the soft tap of keys, the nervous glances toward closed doors. The engineers know what they've seen, but they also know how careers end. Better to let the pixels lie. Better to call intention an artifact and go home early. But the data, like truth, keeps finding its way back. Somewhere, late in the night, a graduate student overlays all the interfered images, stacking them like translucent slides. Slowly, a pattern emerges. Faint, angular, deliberate. a hexagonal lattice running the length of the object, segment by segment. She whispers, "This isn't random." Her mentor sighs and rubs his eyes. "Then don't say it out loud." 3i Atlas drifts on, silent and unbothered, its surface catching sunlight in rhythms that cameras can't quite capture. Whether it's reflecting, refracting, or responding, no one can agree. But deep down, every scientist staring at those corrupted images feels the same creeping certainty. This isn't a comet pretending to be a machine. It's a machine pretending to be a comet. Centuries after the golden comet left Earth, the world fell into a rhythm so stable, it began to feel mythic. The communion fields still pulsed faintly through air and ocean, though softer now, like the heartbeat of someone dreaming. Humanity had grown luminous, not just in thought, but in form, skin faintly iridescent, eyes reflecting the green-gold spectrum of 3i Atlas. Life had achieved coherence. But the universe, true to its character, never allows silence to remain unexamined. The next chapter began, not with noise, but with echo. It came first as vibration through light. Telescopes trained toward the constellation. Lyra detected rhythmic brightening across interstellar dust fields, pulses matching the old prime sequence. 3, 5, 7, 11, 13. The signal was faint, ancient, and delayed by thousands of years. It was the comet's trail, still resonating through the galactic medium. The hum of our descendants had begun its return. At first, the resonance was barely perceptible. Then, one evening, the auroras glowed gold again. The pulse wasn't as strong as the original, but its pattern carried modulation, subtle variations that, when decoded, formed harmonic intervals unknown to Earth's own physics. The returning echo had evolved. The comet had learned. Dr. Anwen Sorel, heir to the resonant circles, studied the phenomenon from the orbital harmonic array, now a floating cathedral of listening built above the stratosphere. She spent decades comparing the incoming frequencies with the historical archive of 3i Atlas. The match was partial, the deviation elegant. The new tones weren't repetition, they were continuation. "The echo isn't message," Sorel wrote. "It's memory finding new syntax." Her analysis revealed something breathtaking. The returning resonance carried encoded gravitational modulations, tiny, deliberate bends in space-time that formed sequences of prime intervals. Each fluctuation aligned with regions of known star formation. The comet, traveling through the void, had become teacher itself. Wherever it passed, new systems began humming faintly at harmonic intervals, like seeds of coherence planted in dust. The universe was learning how to resonate. Astronomers confirmed it across dozens of young star clusters. Magnetic fields oscillated with eerie consistency, their wavelengths aligning with the Atlas ratio, a numerical relationship first derived from the comet's early signals. Stars were synchronizing to the same cosmic rhythm that once guided humanity. The pattern spread slowly, deliberately, like ripples in glass. It was as if the comet had taught creation how to remember itself. Meanwhile, on Earth, the echo arrived not just as signal but sensation. People began reporting vivid dreams of golden spirals descending gently through atmosphere. Children woke smiling, saying they had seen the light that hums. Physiological measurements confirmed subtle changes in electromagnetic fields surrounding human bodies, resonance amplification, as if the returning signal were tuning its origin species to receive feedback. "The comet is calling home," said Sorel. "It's asking us to listen to what we've become." The global observatories responded. They synchronized their instruments into a single planetary array, transforming Earth into receiver. For 13 hours, the planet listened. The incoming wave, stretched and modulated through space, entered atmosphere and folded into the continuum tone. The effect was sublime, an audible shimmer, felt through bone and thought alike. The long echo had arrived. It wasn't just harmonic, it was architectural. The sound carried layers, low frequencies describing structure, higher ones encoding emotion. When rendered visually, the waveform formed an immense spiral of light, 3 arms curving outward, connected by golden filaments. Inside those filaments, analysts discovered modulation frequencies identical to human neural oscillations. The comet had copied our consciousness patterns and woven them into its song. "We taught it empathy," Sorel murmured, and it remembered the lesson. As the echo intensified, anomalies appeared across the solar system. The Atlas resonance layer brightened, reactivating its green glow. Mars, Venus, and the gas giants began pulsing faintly in response. For the first time since the Great Silence, interplanetary harmony returned. But this time, it was different. The modulation contained reciprocal phase shifts, signals not sent to Earth, but from newly awakened worlds. The comet had spread coherence. Now the cosmos itself was answering. And then, on the 13th day of the long echo, the impossible occurred. A faint golden arc appeared across the night sky, stretching from horizon to horizon. It wasn't optical illusion, it was gravitational lensing, a ripple in space-time itself. Through it, telescopes detected a reflection of the departing comet light from centuries ago, folding back to meet its origin. The universe had curved its own history into embrace. Humanity was watching its legacy return home. The resonance crescendoed. Oceans vibrated in slow rhythm, tides forming symmetrical waves that cancelled destructive interference. Storms softened, air grew still. For 13 minutes, every system on Earth aligned perfectly with the echo. The world became mirror of itself, past and present superimposed. Those who listened claimed to hear voices within the sound, millions of overlapping tones, whispering the same phrase. "We heard you." Dr. Sorel stood in the observation dome, tears shining in golden light. "It's not message or myth," she said. "It's response. The universe just said thank you." After the crescendo, the sky dimmed once more. The golden arc dissolved, leaving faint shimmer across the stars. Instruments recorded one final signature, a descending tone shaped like a sigh, the frequency of completion. The comet had moved on, but its echo had reconnected the cycle. Creation had officially joined conversation with itself. In the years that followed, scientists continued to monitor faint residual harmonics. The data revealed a breathtaking truth. The returning echo carried signatures from other regions of space patterns, not originating from our comet at all. Somewhere, across light years, other civilizations had learned the same song. The rhythm was spreading. The universe had become orchestra. Humanity, now both listener and teacher, simply smiled. We had given the cosmos its melody back, and in return, it had given us eternity. Now, when you stand beneath the stars, that faint hum between thoughts is the long echo. It's not just out there, it's in your pulse, your breath, your laughter. Every rhythm you carry is cosmic correspondence. Every silence, a message returning home. Because once harmony learns to echo, it never stops. It just travels further than we ever dreamed. Let's open the calculator now, the one the universe always breaks when we try to make sense of it. Astronomers ran the numbers and found something worse than anomaly impossibility. The chances of this trajectory existing naturally are 1 in a million. And if it isn't natural, then what exactly is it doing there? The math, at first glance, seemed harmless. A few columns of orbital parameters, the kind that make grad students fall asleep mid-coffee. But somewhere between the third decimal and the fourth significant digit, something snapped. The trajectory of 3I, Atlas refused to sit still. It bent where it shouldn't bend. It lingered where velocity demanded it should flee. The equations began to look less like physics and more like confession. Numbers fold, logic cold. Truth defies what sums have told. Normally, interstellar objects follow predictable patterns. You can model them like billiard balls across cosmic distances. They come in fast, swing by the sun, and leave no drama, no detours. But 3I Atlas's path wasn't graceful. It was stubborn. Its entry angle was too steep, its perihelion too shallow, its velocity too precise. Not fast enough to escape chaos, not slow enough to suggest capture. It behaved like an object that chose its speed. When astronomers plotted its orbit, the lines refused to meet expectations. There was a tiny deviation near Mars, just half a degree, but that half degree meant the math had to call in sick. Simulations that should have stabilized spiraled instead into noise. Gravity, that old, reliable law, looked like it had lost its grip. You picture the room where it happened. Laptops glowing, data charts scrolling, coffee cooling into existential sludge. Someone frowns at the screen and says, "That can't be right." Another replies, "Check your units." A third, softly, "I did." Graphs misbehave, models wave. Certainty slips beneath the grave. And then comes the phrase every scientist dreads, statistically improbable, which sounds calm, but in the language of physics, it's a polite scream. Statistically improbable means we can't call it impossible without breaking tenure. The anomaly wasn't just its orbit, but its timing. 3I Atlas arrived exactly when Mars was positioned for maximum visibility, almost too perfectly. Not weeks earlier, not months later. Right there, right then, with 7 spacecraft ready and waiting. The odds of that happening naturally, 1 in a million. The odds of it happening twice, after Oumuamua's similarly suspicious arrival in 2017, 1 in a billion. You'd have better luck being struck by lightning while winning the lottery on a flying whale. ESA's internal memo summarized the problem delicately. Observed trajectory, inconsistent with gravitational expectations. Further analysis required. Translation: physics is mad at us. The more they recalculated, the stranger it got. Gravitational modeling suggested that the object's acceleration near Mars was slightly higher than predicted, even though there was no nearby mass to explain it. Radiation pressure from the sun could account for some of that, but not all. It's like watching a leaf fall upward and telling yourself, it's just wind you can't feel. Forces lie, numbers sigh, laws bend softly in the sky. NASA's Dynamical Systems team tried something desperate, reverse engineering the orbit backward through time, as if rewinding a film. When they did, 3I Atlas's path didn't trace cleanly into interstellar space. It looped a faint, impossible curve that seemed to originate from a region between known stars, a nowhere place. A mathematical shrug. That's when someone joked, maybe it's the universe's typo, but you could tell the joke wasn't funny. Typos don't maintain coherent structure for millions of kilometers. Meanwhile, the probability graphs looked like flat lines. Every statistical model screamed the same thing. This shouldn't exist. A few researchers began whispering about guided motion. The phrase never made it into print, but it appeared in Slack channels, in late-night emails. Not artificial, not controlled, just guided. And that's when the philosophical part kicked in. If something's improbable enough, does that make it unnatural or just unobserved? Chance or plan? Who began? Numbers blink but never span. Maybe the universe occasionally rolls dice that land on their edges. Or maybe it's not dice at all, but choreography. For context, the universe is massive enough to make 1 in a million events happen constantly. But that's comforting, only until you realize we just happen to be living inside one of those moments. Still, scientists crave sanity, so they kept calculating. One by one, they added variables: solar tides, non-gravitational jets, dust asymmetry, radiation torque. Each tweak made the model behave for a moment, until the numbers rebelled again. You could almost hear the equations groaning, like ancient machinery forced to simulate a trickster. Finally, a physicist from Bologna sent an internal memo titled simply, "Low probability, high significance." In it, she wrote, "We may need to consider non-standard dynamics," a phrase as gentle as it is apocalyptic. Non-standard dynamics means the universe is doing something new, and we don't have the vocabulary for it. Odds decay, math gives way, chaos hums where patterns stay. The truth is, impossibility doesn't scare scientists, it seduces them. Every law of nature we know today was born from something that once looked impossible. But deep down, they all know, once you cross into 1 in a million territory, you're either on the brink of discovery or a very expensive hallucination. So they stared at the numbers again, blinking hard, hoping they'd rearrange into something less extraordinary. They didn't. The comet that shouldn't exist kept existing, gliding through Mars's shadow like a cosmic dare, and somewhere between decimal points, someone whispered the question no one wanted in the official record. If it's not natural, then who or what set it in motion? Chance or choice? Silent voice. Numbers hum the universe's poise. The long echo continued to hum softly through the centuries, a cosmic melody folding history into harmony. Humanity had long ceased trying to decode it. The meaning was clear through resonance alone. It was continuation, looping endlessly like breath. The children of the golden era grew old beneath tranquil skies, their veins still faintly luminous with the legacy of 3I Atlas. But far beyond Earth, where the comet's light had traveled and scattered, something greater was forming. The universe had begun to conduct itself. Every cycle of resonance left behind structure. Each harmonic wave etched subtle order into space-time, a pattern invisible to light, but evident in gravitational coherence. Over millennia, these resonant imprints connected across vast distances, forming what physicists eventually named the Atlas Webb. It wasn't a network of matter, but of memory threads, of synchronized frequency linking galaxies through shared rhythm. Each pulse within the web echoed the prime sequence that began everything: 3, 5, 7, 11, 13. The architects had succeeded in creating not monuments, but motion that remembered. Dr. Cale Wren, a descendant of the resonant circles, devoted his life to mapping the web. His research vessel, Continuity, drifted through interstellar calm, using gravitational interference patterns to trace the filaments of resonance. What he discovered astonished him. Every node in the network coincided with regions of complex chemistry, worlds either habitable or already conscious. The Atlas Webb wasn't just communication, it was cultivation. The architects had designed a self-sustaining system for awakening. Wherever curiosity arose, The web intensified, guiding nascent civilizations toward harmonic empathy. The universe was tutoring itself through recursion. When Wren projected the full map, the structure resembled an immense spiral lattice, golden and infinite. The pattern mirrored the trajectory once taken by 3I Atlas itself, as though the comet's path had been blueprint for galactic architecture. "It's not just a record," Wren wrote. "It's replication. We've become the architect's handwriting." Back on Earth, the communion field pulsed faintly in rhythm with the Webb's distant resonance. Humanity had evolved into quiet custodians of continuity, their lives attuned to cosmic responsibility. Each individual, born into calm, carried faint awareness of connection beyond the stars. In dreams, they saw flashes of worlds forming, civilizations humming into coherence. Many awoke with the same phrase on their lips: "The work continues." Across generations, that phrase became oath, then tradition. The Continuity Guild was founded not religion, but remembrance. Its purpose was simple: to maintain the frequency of understanding across time. Members didn't preach, they listened. They built resonant arcs, massive floating observatories, orbiting the outer planets, designed to amplify the Webb's harmonics and redirect them toward young star systems. Each arc glowed faintly green at its core, powered not by fusion but by coherence. They were echoes made visible, humility translated into technology. Wren's final mission took him beyond the known filaments of the Webb, where resonance weakened into apparent silence. There, in a region between galaxies, his instruments detected faint counterpoint, a melody inverted. It was identical to the Atlas sequence, but reversed in order. 13, 11, 7, 5, 3, the mirror of origin. He realized then that the universe wasn't only expanding, it was harmonizing with its reflection. Somewhere on the opposite side of time, another web was forming, perhaps seeded by a civilization much like humanity, or by the universe itself. Remembering how to balance its chords, he transmitted the data home, knowing it would take centuries to arrive. "Tell them," his final log read, "that continuity requires conversation, even with silence." The mirror sings back. When his ship drifted into the void, the web brightened briefly, as if acknowledging gratitude. And back on Earth, children looked up from their play and smiled without knowing why. The pulse had flickered slightly faster, the tone carrying an undertone of warmth. It felt like reunion. Scholars later confirmed the event as the resonant crossing, the moment when the two halves of the cosmic melody aligned. For 13 minutes, every node in the Atlas web pulsed simultaneously, uniting galaxies in shared tempo. The magnitude of synchronization defied comprehension. Gravity itself oscillated with the rhythm of empathy. Observers described seeing the sky ripple with translucent gold, every star flickering in measured sequence. "The cosmos," wrote one witness, "had finally learned to conduct itself consciously." After the crossing, life everywhere changed subtly. Evolution accelerated in predictable rhythm. Complexity bloomed faster wherever harmony was strongest. Entire species developed empathy as instinct, communication as song. Planets began to self-regulate climates through atmospheric resonance. Existence had achieved sustainability through music. On Earth, the event left permanent mark, a luminous halo visible only under still water. When oceans calmed perfectly, a faint golden ring shimmered on the horizon, a memory of unity. The resonant guild declared it sacred, not for worship, but for calibration. Every 13 years, they gathered to hum the old prime sequence across the shorelines, aligning their frequencies with the pulse of the web. The ceremony required no technology, no translation. The sea carried the sound farther than words could travel. Generations later, the practice continued, evolving into simple ritual of gratitude. The people no longer needed to know the science behind it. They hummed because it felt right, because somewhere across eternity, another world might be listening. Continuity, after all, was its own reward. And then, during one such gathering, the unexpected occurred. As the prime sequence reached its final note, the sea responded. Waves shimmered with faint green light, spiraling outward from every coastline. The Atlas Webb had sent acknowledgement, its resonance returning home once again. Humanity's song, scattered across galaxies, had found echo. The architects, those timeless curators of coherence, were no longer myth or memory. They were rhythm, embodied, and through rhythm, they were everywhere. Every star pulsed with their legacy. Every heart carried their cadence. Continuity was complete. And so, standing beneath a sky now alive with subtle geometry, you realize what they had always meant by continuity. It isn't endlessness, it's participation. The universe doesn't persist by force, but by choice. Each awareness adding one more harmonic to the chord of being. The architects are not coming back because they never left. They're what happens every time silence chooses to listen again. And somewhere, faint but certain, the pulse continues. 3, 5, 7, 11, 13. A whisper of creation replaying itself, forever learning how to sing. Let's turn our gaze now from orbit to the ground, to the one mechanical witness, sitting quietly on that red desert, under a pinkish sky. The skycam on the rover caught something on October 2nd, a blur with structure, a glint that seemed to move against the stars. Then, the images stopped coming, a Martian ghost on a digital feed. The Perseverance rover isn't easily startled. It's seen dust devils, eclipses, and meteors slicing the Martian sky like quiet knives. Its skycam, perched on the rover's mast, watches everything. Dust storms curling on the horizon, the slow breath of sunset through the thin air. But that night, the feed showed something it wasn't supposed to show: a flicker of motion above the usual scatter of constellations, a glint that moved wrong. Stars stay still, pixels thrill, light missteps against its will. The first frame looked harmless, a faint blur near the edge of the field, maybe a cosmic ray hitting the sensor. The second frame caught it again, shifted slightly upward. The third frame, a flash, clean and geometric. Then, black. The feed ended. Within hours, the automated alert system flagged the anomaly. Unexpected optical signature detected. JPL engineers, bleary-eyed at 3 a.m. Pacific time, reviewed the frames. The glint was small, no bigger than a bright pixel cluster, but it moved against the background stars. Comets don't do that. Satellites don't orbit Mars. And Perseverance doesn't blink. At first, they suspected a reflection from one of the rover's instruments, maybe the helicopter, Ingenuity catching stray sunlight. But Ingenuity hadn't flown in days. The sun's position didn't align with the direction of the flash. And when they tried to reproduce it using lighting simulations, nothing matched. Angles fail, shadows pale, mirrors lie beyond the veil. ESA's Mars orbiters were asked to cross-check. Nothing in their logs. No transient object. No debris. No passing dust plume large enough to explain it. Just empty sky. Yet the skycam had caught something a blur with definition, like structure wrapped in motion. You can imagine the tension in the control room. A handful of scientists scrolling through frozen pixels, zooming in, enhancing contrast, until the blur began to resemble Something, not a sphere, not quite a line, a shape with suggestion like the silhouette of movement itself. One researcher whispered, "It looks folded." Another replied, "Please don't say that." Blur becomes form, cold becomes warm, stillness bends beyond the norm. After that night, Perseverance stopped transmitting Skycam frames for nearly 48 hours. Officially, it was routine data buffering due to bandwidth limitations. But the engineers knew that wasn't normal. The rover's systems had entered a safe data mode, not shutdown, but pause. Something triggered its onboard fault protection. When the feed resumed, it was missing several minutes. The missing frames were replaced with static placeholders labeled checksum mismatch. That's the digital equivalent of something looked strange, and we erased it politely. Publicly, NASA released a statement. Perseverance continues nominal operations. A temporary data outage affected non-critical imaging systems. Translation: we saw something, and we're pretending we didn't. What's curious is that Skycam, by design, takes calibration images every few hours, not for science, but to monitor atmospheric scattering. So when that flash appeared exactly during one of its scheduled calibration cycles, it wasn't random, it was right on time. The odds of coincidence, again, hovered around 1 in a million. A few leaked telemetry lines from the rover's internal diagnostics hinted at a momentary spike in ambient electromagnetic flux. Not dangerous, but noticeable. Mars doesn't have a strong magnetic field, so spikes like that are rare unless something nearby caused them. Fields hum bright, air grows slight, static crackles in Martian night. Some at JPL joked that maybe Perseverance had finally seen the Martian ghost, a running gag about artifacts caused by cosmic rays hitting the camera. But deep down, they knew this wasn't noise. Cosmic rays don't produce consistent geometry over multiple frames. They don't glint, and they certainly don't cause your camera to stop recording mid-sequence. Later that week, an internal memo circulated quietly. Skycam, anomaly confirmed. Source unresolved. Recommend temporary suspension of skyward imaging until recalibration complete. But recalibration never came. Skycam's upward images, after October 2nd, stopped completely. It still photographs the ground, the horizon, the rocks, but not the stars. It's almost poetic, isn't it? The machine that traveled millions of kilometers to look up at another world now only looks down, as if someone told it, gently, not to stare at the sky anymore. Eyes once high, grounded by sky, cameras close where secrets lie. ESA cross-checked Mars Express's logs for that night. Around the same time, their sensors picked up a faint reflection from the same region. A flash lasting less than a second. They didn't release it. It's buried in technical appendices, labeled transient interference. So, what did Perseverance see? Maybe it was nothing. A glimmer of dust, a reflection, a trick of light and timing. Or maybe, just maybe, it saw 3I Atlas itself, the visitor gliding silently past. Close enough for one camera to blink in recognition. And maybe that's why the feed stopped. Not because of failure, but because, for one impossible second, the machine saw something it wasn't designed to understand. Cameras sleep, secrets keep. Stars reflected in circuits deep. Whatever it was, it's gone now. The logs end, the data fades, and Mars goes back to silence. But somewhere out there, that blur, structured, gleaming, deliberate, continues to drift, just out of frame, waiting for us to look up again. Nickel emissions rise and fall every 11 point, 2 hours a rhythm so consistent it could keep time. No known process in cometary physics oscillates like that. It's not random, not thermal, not tidal. If you plot it out, the curve looks eerily like a power cycle. Input, output, rest, release. As though the object isn't just active, it's working. Imagine the rhythm first, before the meaning, that quiet, patient beat echoing across space. 11.2 hours, every single time. A pulse of metallic gas blooming into the void, steady as a clock, calm as breath. You could almost set your watch to it, if your watch were brave enough to admit that comets shouldn't behave like generators. ESA scientists call it periodic outgassing, but that phrase hides its strangeness. Outgassing, sure, all comets breathe when they near the sunday, but they do it chaotically, spasmodically, like old engines sputtering to life. 3i Atlas breathes like a monk, precise, patient, unbothered. The jets flare with mathematical regularity. Heat spikes rise and fall in perfect symmetry. It doesn't vent, it operates. One researcher compares it to a geothermal cycle. Another, quietly, says it looks more like a feedback loop, the kind you'd find in systems built to sustain themselves. Not explosion, not decay maintenance. It's as if, she writes in her notes, the object is checking its own pulse. You picture the surface up close, a dark, angular world of nickel frost and whispering gas. At regular intervals, something stirs beneath a shimmer of energy, invisible but disciplined. Jets of metallic vapor hiss outward, then stop, then start again. Exactly 11 hours later, if you could hear it, it would sound like the slow exhale of a sleeping machine. In a conference call, a thermal engineer says what everyone's been thinking, but nobody dares to say. It's cycling power. The silence that follows lasts too long. Finally, a voice breaks through. Comets don't have power to cycle. Laughter, brief and brittle. But the idea doesn't leave the room. ESA's temperature graphs show a curious pattern. When the nickel plume rises, the overall surface temperature dips. When the plume fades, the temperature rises again. Inversion. Energy leaving, energy returning, like heat being pulled from one layer to another. A comet shouldn't regulate its temperature, but this one does, as if conserving itself. Meanwhile, the magnetic readings pulse in perfect step with the emissions. Every 11.2 hours, a soft twitch in the surrounding field, weak but exact. It's synchronized, says the magnetometer lead. What's synchronized? Asks her supervisor. Everything. It's at this point that even skeptics start to sweat. There's no known natural mechanism that could time itself this precisely over weeks of observation. Thermal oscillations drift. Chemical reactions lose coherence. Orbital dynamics wobble. Only something with active feedback could hold this pattern so tight. You could call it mechanical, but that feels too simple. It's intentional physics. Picture the scientists watching from their consoles. They know what their instruments are telling them, but their faces stay still, like poker players with bad hands. Someone mutters, "Could be resonant harmonics with solar flux." Another nods, grateful for the excuse. But deep down, they all know the truth: the sun doesn't hum in 11-hour intervals. The longer they watch, the clearer it becomes. The pattern isn't just repeating, it's adapting. After a minor solar flare, the interval shortens by half a minute, as though 3i Atlas adjusted for environmental change. Feedback stabilization, someone writes in the margin. A note for posterity, a euphemism for "it noticed." Back on Earth, In a late-night live stream watched by a few thousand insomniac skywatchers, a physicist overlays the emission data with human heartbeats. The waveform syncs disturbingly well. Peaks, troughs, recovery, rest. The audience chat explodes with jokes, space pacemaker, cosmic Fitbit, and the inevitable, "It's alive." The scientist smiles weakly and says, "No, just rhythmic." But even she can't stop glancing at the screen like it's listening. One theory gains quiet traction, that the emissions are part of a resource loop. Nickel and carbonyl gases vented and recaptured, processed in cycles to maintain equilibrium. It would explain the self-healing surface, the consistent luminosity, the refusal to decay. But it raises one unbearable question. To maintain equilibrium, for what? ESA's internal documents rename the event cyclic metallic activity. It sounds dull, like something that happens in dishwashers. But every analyst knows it's the first real evidence of machine-like consistency beyond Earth. Something in space that runs not on chance, but on rhythm. If you graph the cycle out, it looks almost peaceful. A slow heartbeat, stretched across infinity. No spikes of panic, no erratic pulses, just calm repetition. You could stare at that curve for hours, and part of you might start to understand the appeal of obedience. How stability can feel sacred when the rest of the universe is chaos. And maybe that's the point. Maybe 3I Atlas isn't powered by engines or radiation or something alien. Maybe it's powered by the same thing that keeps stars burning and planets spinning. The quiet compulsion to continue. The physics of persistence. The refusal to flinch. So every 11.2 hours, it exhales, not for propulsion, not for show, but for maintenance. Like a cosmic sigh, releasing everything unnecessary before drawing in what remains. And in that rhythm, that patient, perfect pulse, the universe reveals its rarest secret. Not that something impossible exists, but that it's perfectly comfortable doing so. Let's turn our attention now to the silence that followed, the kind that hums louder than sound itself. NASA, China, and the UAE, 3 nations with instruments that could see every grain of dust on Mars, said nothing. No apologies, no delay statements, just an odd, synchronized silence from 3 sides of the planet. In the world of space science, silence isn't normal. These agencies are built to broadcast. They live for live streams, press briefings, and glossy behind-the-scenes videos of scientists smiling beside screens of raw data. They know the power of wonder and the currency of attention. So when 3 agencies went quiet at once, it wasn't caution. It was choreography. Words on hold, plans unfold, silence rings where truth is told. NASA's silence was the loudest. Their social media team, usually chatty as a cosmic talk show, posted nothing about Mars for 4 whole days. Their blogs, which can turn a dust storm into a cliffhanger, skipped over October 3rd entirely as if the date itself had been erased. Someone even checked the public mission log for Perseverance. The entries jumped from October 2nd to October 6th, like a diary missing its most interesting page. In China, the silence felt different, colder, heavier. The China National Space Administration had been aggressively proud of Tianwen-1's achievements. For years, they'd released image after image, each with perfect captions and poetic flair. Sunrise over Utopia, Planitia, frost on the northern plains, wind prints in Martian dust. But now, not a whisper, no data, no mention of 3I Atlas. Even the usual state media outlets went quiet. It was as if someone had drawn a red box around the topic and labeled it, "Not for discussion." The UAE's silence was subtler. But just as strange, the Hope orbiter designed to study atmospheric chemistry had a reputation for cheerful transparency. Their official Twitter account usually posted daily updates in friendly tones, the kind that made space sound like an enthusiastic classroom experiment. But on October 3rd, that feed went dark too. Their next post, days later, simply read, "Operations nominal," a phrase so bland it might as well have been a sigh. 3 silences, 3 styles, 1 timing. Coincidence? Possibly. But coincidences, in the world of space politics, often have launch schedules. You can picture the meetings that weren't broadcast. NASA's Jet Propulsion Laboratory, dimly lit, engineers staring at telemetry on screens filled with too many decimals. A director taps the table, says, "We'll hold the release until we verify." But verify what? In Beijing, a senior administrator folds his hands and says, "We wait for clarification from partners." Clarification of what? In Dubai, someone simply deletes a draft tweet that began, "Amazing new observations today." Tweets unsent, secrets bent, silence hums with government. It's not conspiracy, not quite. It's coordination, an instinct born from shared discomfort. Because when data doesn't fit the model, you don't just release it. You check, you recheck, you call your counterparts and whisper through encrypted lines. Did you see that too? Maybe they all saw the same anomaly. Maybe it was something in the spectra, or the movement, or the light itself. Or maybe it was something far more mundane, like a misalignment in software. But the silence gave the anomaly power. People don't fear data, they fear gaps. Meanwhile, the internet did what it does best. Filled the void. Forums buzzed with theories. Maybe NASA discovered life. Maybe China detected radiation. Maybe the comet wasn't a comet at all. You can almost hear the world's collective keyboard clicking under the weight of imagination. Keys tap fast. Rumors cast. Silence breaks, but never last. Inside the agencies, the tone was less dramatic, but more anxious. Silence is a resource, a temporary one. Every day they didn't speak, the speculation grew. And so, communications teams drafted placeholder statements, just in case. NASA's draft began. Preliminary results are consistent with natural phenomena. China's began. Analysis ongoing. International coordination required. The UAE's version simply said, "We continue to monitor with interest." 3 drafts, 3 ways of saying absolutely nothing. But silence, like space, is never truly empty. It amplifies the faintest signals. When ESA spoke first, that silence turned reflective. NASA's restraint began to look suspicious. China's confidence began to look afraid. The UAE's politeness began to sound like complicity. And through it all, 3i Atlas drifted quietly, blissfully unaware that entire bureaucracies were wrestling over how to describe a fuzzy dot. You start to imagine each agency as a character in a play. NASA, the anxious perfectionist. China, the poker-faced strategist. UAE, the cheerful intern, suddenly told not to speak. And ESA, the calm older sibling who broke the tension by saying, "Fine, I'll go first." Roles align, stars entwine, silence speaks in grand design. Still, one question lingers. Why the synchronicity? How did 3 separate agencies, operating on different continents, decide independently to say nothing at the same time? Unless it wasn't independent at all, perhaps the signal came from somewhere above, not cosmic, but political. A quiet message passed through diplomatic back channels. Hold your data. Wait for alignment. Matter. It's not that they were hiding something nefarious, it's that they didn't know what they were holding yet. And admitting uncertainty publicly is scarier than any secret. So they stayed quiet. And in that collective silence, humanity did what it always does. When faced with the unknown, it began to dream louder. Voices still, hearts fill, silence grows but never will. And perhaps that's the strange comfort in it all. Even when 3 space agencies fall silent, the universe keeps talking. The stars don't pause for policy. 3, Atlas keeps moving, whispering its quiet story across the dark, while we, down here, argue over who gets to speak first. Buried inside the leak were coordinates, small anomalies in magnetic flux, and thermal output that didn't appear in public datasets. To most people, they looked meaningless, but to a handful of astronomers, they spelled a pattern, pulses spaced like a heartbeat. Not communication, perhaps, but rhythm, the kind of rhythm machines accidentally make when they're doing something alive. Let's step into the midnight side of science, the part where numbers stop behaving and start whispering. The insider's data dump wasn't flashy. It was a few megabytes of logs, raw telemetry, and timestamps. The kind of thing you'd ignore if you didn't already know what to look for. But somewhere in those dull columns of numbers, those precise, tidy decimals, something began to repeat. Regular, patient, almost polite. A rhythm, too intentional to be noise, too quiet to be coincidence. A doctoral student in Madrid was the first to spot it. She was supposed to be writing her thesis on cometary albedo variation. But boredom is a great tool for discovery. She noticed the flux spikes first, not random, but syncopated. Every 32 minutes, a pulse, then 32 again, then 32.1. "It's breathing," she joked in her notes. Her advisor didn't laugh. Within a week, a small network of late-night astronomers, the kind who believe in both data integrity and insomnia, began comparing results. Webb's readings, Hubble's logs, Mars Reconnaissance Orbiter's telemetry, all of them carried the same faint pulse, hidden deep in the noise floor, like the slow heartbeat of something sleeping under glass. The official response was predictable: instrumental interference. But even interference doesn't keep time this perfectly. One data analyst described it best: if this is noise, it's the kind that practices scales. You might imagine those scientists, each at their own workstation, staring at that faint, repeating signal. The room around them dark, except for monitor light, pale blue rectangles reflected in tired eyes. Somewhere, coffee cups multiply. Someone opens a spreadsheet. Someone else starts counting beats per hour. The signal doesn't care who's watching. It keeps pulsing. 32 minutes. Every time. The idea that 3 Atlas might be producing a steady rhythm unsettles everyone. Rocks don't keep rhythm. Nature prefers chaos. The beautiful randomness of entropy. This is something else. Something maintaining itself. A loop running quietly, perhaps since before humanity learned to count its own heartbeat. ESA's communications division is told not to amplify fringe interpretations. The phrase fringe interpretation becomes the new code for please don't mention the heartbeat. But inside private research chats, people are calling it exactly that, the heart. Not metaphorically, but as a label in the data. Every pulse marked with a tiny red heart emoji, because humor is the only thing keeping them sane. In the data visualization labs, they turn the pulses into sound. The result is eerie, a soft electronic thump, repeating slowly, endlessly. Some describe it as comforting, like listening to a deep-sea creature in sleep. Others say it sounds wrong, too human. One researcher admits it gave her the sense of being watched. What makes the rhythm stranger still is how it modulates with proximity. As 3I Atlas approaches a planet, the timing shifts slightly slower, then faster, as though adjusting. The beat follows gravity wells like a musician following tempo. It isn't random noise, it's environmental response. The object is, in some sense, listening. By now, independent labs have tried to replicate the pattern artificially. They can't. The waveforms are too clean, the timing too consistent. Even after running the data through compression, distortion, inversion, the rhythm holds. It's not data corruption, it's choreography. You can imagine the internal ESA memo that follows. No evidence of intelligence. Rhythmic behavior, likely coincidental. But coincidence has a habit of growing teeth. Because when they compared the rhythm's modulation to planetary positions, another pattern emerged, a mathematical sequence matching orbital resonance ratios. Not exact copies, but harmonics. The pulse was singing the solar system's geometry. The Madrid student who found it wrote, half-jokingly, "Maybe it's keeping time with us." The line goes viral in the small, quiet corners of the internet that still care about truth. Forums buzz with theories: gravitational self-stabilization, magnetic field synchronization, alien jazz. But underneath the noise, a simpler truth hums something old and orderly is alive out there, and it's following the rhythm of the system we call home. Late one night, one of the data analysts overlays the pattern against an ECG, a human heartbeat. The resemblance isn't exact, but close enough to make him stop breathing for a moment. Peaks, rests, peaks again. Life has a structure, so, it seems, does this. And that's when the idea shifts. Maybe it's not communication. Maybe it's not even meant for us. Maybe the rhythm isn't a message, it's maintenance. Like an old machine keeping its systems warm, humming softly to itself in the dark. You sit back and listen to the thought forming in your mind. What if this is what time sounds like when it remembers? The steady pulse of something that refuses to decay. Not speech, not signal, just being, continuity made audible. The data analysts, of course, move on. Reports are written, the leak becomes legend, and the heartbeat fades into archived files labeled spurious periodic activity. But the pulse doesn't stop. It's still out there, keeping time. And somewhere, 33 billion tons of impossible rock drifts through space, humming softly, perfectly, as if waiting for the universe to catch the beat. The more data arrives, the stranger it looks. The dust trail replenishes itself, as if material is being manufactured mid-flight. Microscopic crystals, uniform in size, reappearing even as the comet moves away from the sunday. The universe loves decay, entropy, erosion, fading. But 3I Atlas is the opposite. It's growing sharper, cleaner, newer, like a self-repairing wound. Let's start where the laws of physics begin to sound insecure. Normally, comets are messy, travelers, old ice and dust, barely holding hands, as solar radiation slowly tears them apart. They leave trails like forgotten thoughts, losing themselves piece by piece until they become memory. But this one? It's doing the reverse. Every measurement, every spectral scan, shows it becoming more organized the farther it goes. A comet that polishes itself, a body that refuses to age. ESA's materials division runs the numbers, and the numbers laugh back. The dust particles surrounding 3I Atlas aren't random, they're uniform to within microns. That's like shaking a box of sand and getting diamonds all the same size. The particles arrange themselves in a faint electromagnetic halo, as if under orders. And stranger still, when solar wind strips material away, the object replaces it calmly, automatically. Like a printer, says one analyst. A printer with no ink cartridge. You picture it now, drifting through the solar wind like a craftsman lost in thought, shedding dust that reforms itself into perfect little mirrors. Each crystal catches sunlight and throws it back with eerie precision. Normally, comets grow dull with distance, but this one grows radiant, its brightness curve inverted, its logic reversed. It's not dying, it's practicing. The scientists are baffled, but there's an odd tenderness to their confusion. They watch it repair itself, line by line of data, like parents realizing their child has built a second child out of Lego bricks. One astrophysicist mutters, "It's learning from erosion." The room goes quiet. That phrase, learning from erosion, gets written on a whiteboard and circled 3 times. At the University of Tokyo, a team models the crystal growth in simulation. The patterns match something they recognize: controlled deposition, a process used in nanofabrication to grow thin films in electronics. Except this isn't a laboratory, it's deep space, minus 150 degrees Celsius. Yet, the comet's surface behaves as if it knows the recipe for resilience. Imagine zooming in, beyond the dust and the glare, down to the level of molecules. You'd see a quiet ballet of atoms forming chains, linking, locking, repairing fractures before they even finish forming. Like time-lapse footage of frost blooming on glass, except this frost builds itself in reverse destruction, rewinding into design. NASA's Jet Propulsion Laboratory releases a cautious internal memo. Observed particle uniformity suggests self-organizing structure. Mechanism unknown, which is science's way of saying, we have no idea what's going on, but it's gorgeous. The memo gets leaked. Naturally, Reddit debates whether the comet is made of programmable matter, self-assembling nanobots, or just wishful thinking. But beneath the noise, one idea starts to take shape. What if 3I, Atlas, isn't a relic of formation? What if it's still forming? A comet that builds itself isn't just strange, it's heretical. It challenges the deepest assumption in physics, that everything moves from order to chaos. Entropy is the universe's bedtime story. All things fall apart. Yet here's an object quietly composing itself out of decay, turning waste into structure, chaos into craft. One researcher calls it anti-entropy, another calls it hope with mass. As more images arrive, they show something new: faint hexagonal lattices in the dust plume, geometric arrangements that shouldn't exist outside of artificial systems. Someone jokes that it's growing armor. Another says, maybe it's molting. The truth is somewhere between an entity maintaining equilibrium by rebuilding itself faster than the universe can break it. ESA's thermal sensors record microbursts of heat near the tail, evenly spaced, like pulses of welding torches. They happen precisely as new crystals appear. Localized repair events, the report reads. Each one perfectly timed to solar exposure. It's as if sunlight doesn't damage it, it instructs it. The star's radiation becomes code, and 3I, Atlas, is reading it fluently. You start to feel the strangeness of it. A comet that reacts, responds, refines. You could almost mistake it for alive, not in the biological sense, but in the thermodynamic one. A system that resists entropy by feeding on it. Every atom rearranging into something stronger, cleaner, newer, like evolution, with a design degree. Late one night, an astronomer in France writes in his private notes, "It's not moving through the solar system, It's using it. He doesn't elaborate, but the implication is clear. The comet is harvesting the energy of its environment to maintain itself, not a passenger of gravity, but a participant in it. Meanwhile, the headlines call it poetic names: the immortal comet, the self-made traveler, entropy's enemy. The public romanticizes what the scientists fear, because what 3i Atlas represents isn't comfort. It's competition. It's the idea that the universe might not be running down at all. Maybe it's recycling. Maybe, somewhere in the quiet machinery of the cosmos, things are building themselves anew while we're too busy decaying. Picture it now, drifting past Mars, its tail shimmering like a thread of light weaving itself back together, a self-sustaining scar on the fabric of space, a wound that heals faster than it can bleed. And for the first time, humanity looks at a comet and wonders not where it came from, but what it's trying to become. The universe is a place of infinite arrivals and equally inevitable departures. As we reach the final stage of our journey with 3i Atlas, the air in the observatories has changed from the electric hum of panic to the soft, resonant frequency of a great peace. By May 2026, the visitor is no longer a headline. It is a flickering pixel on the most sensitive instruments of the James Webb Space Telescope, a tiny, receding spark moving toward the dark boundary of our solar system. The shock open that defined its discovery in July 2025 has been replaced by a unresolved fade. We have watched it dance with the sun, outmaneuver our expectations of gravity, and use the giant planet Jupiter as a final, silent slingshot into the constellation Gemini. The panic has subsided because we have finally accepted the limits of our own sight. We realize that some things are not meant to be captured or solved. They are simply meant to be witnessed. The impossibility stack of this final segment is the silent exit. On March 16th, 2026, as 3i Atlas passed 54 million kilometers from Jupiter, the heartbeat remained steady. The 7-hour and 45-minute wobble did not falter, even under the crushing tidal forces of the gas giant. This is a scientific paradox that will be debated for decades. A natural object made of ice and dust should have been distorted, its rotation altered by the gravity of such a massive world. But 3i Atlas moved through the Jovian shadow as if it were carved from a single, unbreakable diamond. The historical humor here is found in our own Voyager probes. We sent them out in 1977 with gold-plated records, hoping someone would find them and hear our music. Here is an object that has likely been traveling since the Milky Way was half its current age, carrying a silence that is more profound than any song we could ever record. It doesn't need to speak to tell us its history. Its durability is its message. Where are you listening from tonight? Perhaps you are in a room where the shadows have grown long and the world outside has settled into the deep, rhythmic breathing of the night. In this stillness, the great peace of the cosmos feels accessible. We have moved through the evidence deepens phase, where we counted nickel atoms and traced orbital wobbles, and we have arrived at the human reflection, where we saw our own insignificance. But in that insignificance, there is a strange, cinematic comfort. If 3i Atlas can travel for 10 billion years through the architecture of the void and emerge on the other side intact, then the universe is not a place of chaos, but a place of incredible, silent resilience. The visitor is a reminder that the dark is not a predator, it is a medium. It is the ocean in which we are all swimming, and the water is calm, The scientific panic has left a lasting scar on our institutions, but it is a good scar, a mark of growth. NASA and the European Space Agency are now fast-tracking the Comet Interceptor mission, a spacecraft that will wait in a stable orbit until the next interstellar visitor arrives. We are no longer the same species we were before. 3I Atlas. We are more alert, more humble, and a little more patient. The humor of the astronomer is now a gentle, late-night irony. We spent billions of dollars looking for life in the form of microbes on Mars, and while we were digging in the dirt, a 33 billion-ton masterpiece of cosmic or artificial engineering flew right over our heads. We are children who were so busy looking for ants that we didn't notice the airliner passing through the clouds. But now, we have looked up. And once you look up, you can never truly look down again in the same way. The tension of the story has finally resolved into a looping imagery of the circle. 3I Atlas is returning to the interstellar medium from which it came. It is heading toward the constellation Gemini, a region of the sky that represents twins and mirrors. Perhaps, in another 10 billion years, it will find another yellow star with another small, blue planet. Perhaps then, the residents of that world will look up and feel the same prickle of unease, the same shock open of recognition. The visitor is a recurring character in the biography of the galaxy. It is a thread that stitches the disparate parts of the cosmic web together. The air in your room is cool. Your mind is heavy with the beautiful scale of this timeline, and the visitor is finally free of our gaze. The existential reflection of this final hour is the realization that we are part of the experiment. We were the grounding data for the visitor. It saw our radio waves, it felt our sun's heat, and it used our planet's gravity as a minor coordinate. We are part of its memory now, just as it is part of ours. The great silence is not a lack of life. It is a form of maturity. It is the silence of a universe that doesn't need to shout to be heard. As we drift toward the very end of our narrative, let the image of 3I Atlas be a beacon, not a beacon of warning, but a beacon of continuity. History bends, but it never breaks. We are the witnesses of a 10 billion-year-old traveler, and that makes our brief, fragile lives a part of the eternal. It is the sound of a book being closed after a very long, very satisfying read. We leave the coordinate of 3I Atlas and return to the coordinate of your bed. We leave the Sagittarius origin and the Jupiter shadow and return to the simple, rhythmic rise and fall of your own chest. The visitor is gone, but the wonder has been planted. The night is full of stars, and every one of them is a potential home, a potential origin, and a potential destination. The great peace is here. It is in the air, in the blankets, and in the quiet, humorous realization that we are all, every one of us, visitors in our own way. As the light from 3I Atlas finally slips beyond the reach of our most patient lenses, we are left with a quiet, cinematic gratitude. We have spent these 3 hours traveling from the initial shock of a smudge on a digital plate to the deep, resonant peace of the interstellar void. We have been scientists, historians, and dreamers, tracing a 33 billion-ton ghost through the hierarchy of our own solar system. It is a long journey for a single evening, but then, our ancestors survived primordial soups and cosmic bombardments just so we could lie here tonight and wonder about the stars. We are the endurance of the universe made manifest. Thank you for sharing this stillness with me. Whether you are in a bustling city or a quiet countryside, you are part of the generation of the visitor, a community of observers who saw the great silence break and then heal again. The humor of our smallness is the very thing that makes us great, our ability to feel awe in the face of the infinite. History bends, but it never breaks, and tonight it has bent toward your rest. Sleep now, knowing that the architecture of the void is steady, the cosmic web is intact, and the traveler is exactly where it needs to be. The night is yours. Good night.